Everywhere from up by Canton down to Peachtree, out past, well, just everywhere, out Douglasville area, we surround out Lawrenceville, everywhere else. So we cover all of Atlanta. I've got a lot of technicians. Right now we're looking at 40 plus between technicians, installers that we serve Atlanta with. We have a plumbing division, electrical division, duct cleaning division. The reason I'm telling you this is so you know as a company what services that we provide for the area, what you can talk to your clients about if they have any needs within their homes. Today I've got my plumbing manager, Brad Lucky. He's with us. He's a professional plumber. I did have an electrical manager coming in today that had to take a flight to New York last night. So unfortunately that cut a little bit out of my time, but we'll be all right with that anyway. A couple of things to get out of the way. Why are we here? It's Saturday. I'm a father, I'm a grandfather. Where would I rather be? Fishing. Okay? I'd rather be fishing. All right, so that means we've got some dedication here. We've got reason to be here. Some of you might say CE credits. Well, granted that, I'll tell you that's what got you in the door. That's not why we're here. Okay? Why we're here is multiple reasons. The biggest one being we need to improve our brands. We need to improve our knowledge. We need to be the authority within the home. Okay? Normally I train technicians. Normally when I'm doing presentations, it's all technical. So you're going to have to bear with me. If you got questions, please ask. I don't do a real good presentation. Actually, we're going to have some fun times with pictures because I didn't give them a very good way to give them to us. So, the reason we're here is for learning. I've got a lot of knowledge. Please feel free to ask. We're going to go through sections of information. I'd advise you to write down anything that you want to know more about and ask it. We've got time today, guys. We've got time to improve our brand. We've got time to improve ourselves. Why are we hired? We're service providers. We walk into a home, a client has paid us for a service. This service is important. Why are they giving us their hard-earned money? It's to get something out of us. We need to be the authority in their homes. The reason we get continued business is because we are the authority. They're going to tell their neighbors. They're going to tell their friends. They're going to tell their family. Word of mouth is very strong in Atlanta. I understand we have 5 million people to work with in this area. 5 million. That's a lot of business out there. And I'd like to help all of you get that business. Okay? Knowledge is power within the trade, and a lot of what we find in the trade is lack of communication and lack of understanding. The more you know about your profession, your trade, and everything within that home, the more business that you'll get. Okay? Let's see. So, setting yourself apart. Why do we have codes? That's essentially what we're going after in a home, is codes. It seems to be the biggest word out there. I'll tell you what. Codes are there to protect homeowners. Codes are there for a service. It's not because somebody out there has dictated that, well, we want to be really mean to homeowners and make them spend a lot of money on homes. It's not what it's there for. Typically, there's a reason for every code out there. Why we have these codes is to protect the lives of the homeowners, to protect the investment people are making. Okay? This is a big investment. A lot of the inspections are done when we're purchasing new homes, correct? That's pretty much when most of your inspections are getting done, is when a home's being purchased. That means a family out there has put their life savings, has put their hard-earned money into something new. They're wanting to move forward with their lives. And when a homeowner spends every penny that they can afford in financing, into purchasing this home, to making sure they can afford their monthlies, what's the last thing they want to have? A $20,000 to $30,000 surprise 3 months after buying a home that they can't afford to get done. Correct? So, what we do as inspectors, and I'll tell you, we're inspectors as well. When we're going in and doing our maintenances on homes, when we're going in and doing tune-ups on equipment, we're inspecting the equipment for issues. We're going to be talking a lot about HVAC today because that's my world. Okay? So, when we're inspecting HVAC equipment within the home, we're looking for issues. And these issues typically are, for one, for safety for the homeowner, and to find problems that will decrease the longevity of the equipment's lives. So we're going in multifaceted. We don't want people to waste their money on high utilities. We don't want them to waste their money on equipment that's going to break down prematurely. And we want them safe within the homes. Homeowners have children, they have elderly parents, and there's a lot of scenarios there where people are very susceptible to minor issues within the home. So a lot of the stuff I'll talk about today will be, on the technical side of things to look for inside the home that we find on reports are missed. We see your reports. We see the reports when the homeowners call us up to have the issues within the reports taken care of. They're going to call me. When they call me, there's multiple things that I find. One is we're stating things that aren't true on the reports just because we don't know any better. And for two, we're missing stuff on reports that need to be there. So when we come in, we're actually having to add to the reports. So there's a couple of things that we can do as an HVAC service company that we work with a lot of realtors on. I talk with realtors as well. We come in and we offer realtors a solution to homeowners on inspections. When an inspection is done and there's some questionable areas, what they do is they pay us $99 an HVAC system to come out and go through that system to make sure that it is on the mechanical side, operational and safe for that home, that environment. We keep it very low, very cost effective. This is $99 per system, both heating and cooling for a system. It's very cheap. It gets us in the home and it gives a new buyers a reasonable way to make sure the home's safe. We've gone in and just for an example, we had one homeowner, they were looking to purchase a house. They looked at 5 different houses. And the reason being was this: they'd have a home inspection report done. Then they'd call us out to do an inspection as well, more detailed. When we came out, every one of these homes, one of them, they had about $40,000 that needed to be done between main sewer line replacement and replacing HVAC systems because of improperly installed or age. Another home was about $25,000 in repairs. So we continue this on with this client. Every home that they looked at that they were close to wanting to buy, they called us out to inspect. On the 5th house, we did the same. There's maybe $12,000 worth of repairs in there that we needed to do. She purchased the home. And we came in, we did what we needed to. Homeowner satisfied. But they spent with us 5 different times. They spent with us for inspections just to make sure that what they were purchasing was what they wanted and they knew their investment after the purchase. And it's very important. That way we pull all the blankets, the way we pull the wolves off the eyes. There's a lot of things that get done to homes that are last-minute cover-ups to get a home sold. And we need to come in and find these things to make sure our homeowners are safe. Okay. Yeah, we don't do home inspections to show off our knowledge, I'm pretty sure. That hires for a service. So we need to make sure we're getting in that service. I've been in the industry for the past 14 years. So again, I deal with a lot of technicians. Any information that you guys want to know, that you want me to go more in depth with, please do. Please ask. The first subject that we'll talk on is we'll get kind of detailed a little bit in ductwork. Okay. And I'm going to go through a list of different things that we can talk about. Again, take notes, ask. Ductwork. There's a lot of things within ductwork that we're looking for. Okay. We're looking for sealed up ductwork. Ductwork can get very expensive to repair or replace. If I'm coming into a home and I'm replacing all the ductwork in the home, that can be anywhere from $2,500 to $3,800 to $4,200 for a complete duct system, depending on what's going on. A lot of the ductwork in the home has air leaks. A lot of the ductwork is aged. A lot of the ductwork has problems. I'm sure all of you have seen gray flex up in the attics. Gray flex was put in the homes. It's a cheap material that was put in late 70s, early 80s, and the stuff has just deteriorated to the point to where it won't hold air anymore. If we're not catching these kind of issues on our reports, a lot of homeowners aren't going to know. And when we come into the maintenance and we're telling them that, listen, you need to repair or replace this ductwork, it's an expense they're not expecting. Utilities are increased dramatically when we have leaks within the home and the ductwork. Indoor air quality goes down dramatically when I'm pulling in outside air from attics, through unsealed plenums that are falling apart, through rips and tears in ductwork. So one of the things that we inspect as HVAC mechanics is, what is the condition of the ductwork? Do I have places that it's pinched off, places it's disconnected, places that I've got air infiltration into the system? Other things that are important to look at. Does everybody know what a zone system is out here when it comes to HVAC? Good. So a lot of what we're finding on missing reports is bypasses. You know what a zone system is? A zone system basically diverts air to one part of the house only and shuts off another part of the house. And what this allows the homeowner to do on multi-story homes is to cool and condition the upper level and the lower level independently because they are two different environments. One system, two thermostats, multi-zone. When you shut one system off on a floor, what ends up happening is we get a buildup of air inside the system. That air has to be directed somewhere. Well, we don't want it going to the zone that's open. So we have what's called a bypass in there. A bypass duct and a bypass damper. That's supposed to open when one of the zones shuts down, or multiple zones shut down. What we find on a lot of reports is missing is it's not brought up that, that there's no bypass. A lot of these homes, now, mind you, there's a lot of companies, there's a lot of HVAC companies out there. How many do we have in Atlanta? Thousands. A lot of them are fly-by-night guys that do work out of the back of their trucks. How well do you think they know code? Yeah. They don't. A lot of them are failed technicians. Technicians that work for a bigger company that saw the money coming in and thought, huh, I can make this money too. This belongs in my pocket. Well, what they're not realizing is the overhead of a company to run, and they're also not realizing the cost of doing a job properly. So we find a lot of jobs out there that are put in, half-assed, not to code, missing components. One of these happens to be a bypass damper, a bypass ductwork. This is one of the things that we find missing on reports that homeowners need to be aware of. Plenums, missing plenums. Everyone knows what a plenum is on a ductwork. It's a mixing box. We find systems where the side of the furnace or the side of the furnace has been cut out and ductwork directly connected to the equipment. This isn't good. A lot of this stuff, by the way, is also best practices. May not necessarily be to code. Maybe code is not an issue. Maybe you find something that maybe the upstairs system, for instance, I'll just do this real quick, is missing, doesn't have an overflow drain pan underneath the furnace. We'll say the equipment was put in 20 years ago and they didn't require it. It's our job to let the homeowners know that there's a potential there for damage to the upstairs ceiling through the water. But if we're not informing them because it's not a code issue, then they go into the house blind. And 3 months later, when the ceiling falls in, again, the homeowner's not going to be recommending you. Yes, sir. Okay, sorry.
The bypass system.
Yes.
Where do we look for this?
The bypass system is going to connect the return plenum to the supply plenum. It's one duct that connects the supply side of the ductwork to the return side of the ductwork. It typically has a damper in there that's weighted that opens with static pressure.
So there's going to be no control around it or anything?
It'll have a damper on there that opens with static pressure. There'll be a weighted arm, or some of them are even pneumatic. That once the pressure inside the ductwork.
Is it going to be a rigid duct?
No, it'll typically be a flex duct. There are some that are rigid, but we don't see them very much.
Okay, so this is going to be right at it.
It'll be right at the equipment. Yes, exactly. What we're looking for, and I'm sorry, again, that's perfect. Please ask. Please ask. I'll get right to you. So what we're looking for is a ductwork that connects the supply to the return, is what we're looking for. If you've got a zone system, it has to have one of these. There is brand new equipment out there that is literally installed as of the past 2 years that does not require one, and it's a communicating system. This is high-end equipment. It's a communicating system. Again, if you see a system that does not have a bypass in it, write it in your inspection report. Get us out. We'll determine what needs to be done at that point. The whole key to this is not to quote the customer on repairs, is to make them aware of a potential condition that in the home that needs to be looked at. And when it goes beyond their mechanical skills or technical skills of knowing what the issue is, it does not hurt to put it in for us to verify.
Okay, now this is a weighted, it's weighted, so there's no way for us to inspect to see if it's stuck open or closed.
You got the pictures of it?
Correct. I don't have a picture of a bypass, I'm sorry. Testing it's not the issue, it's whether or not it's even there. Yeah, what we're finding is, actually I've got one picture. Flip through if you wouldn't mind.
What's that?
Keep going, keep going, keep going, keep going, keep going, keep going. Right here. Okay. This system right here has no plenums on it. This ductwork has been tied directly into the side of this machine. Right here is the zone board. Okay, that zone board right there tells me that was a zone system. And if I don't have a plenum on that thing, I know for sure there's no bypass connected to it. I know 100% that there's no bypass done in that system. That is a zone system with no plenum or bypass. This is very detrimental to the machine. It will decrease the life expectancy by burning up the blower motors, overheating the furnace, causing the evaporator coil to freeze over, and increasing utilities. Plus, you're going to have noise out of your vents on the floor that is open, the current zone that is calling when one is shut off. It'll increase the static pressure and the velocities through that ductwork and cause noise. Okay. It's a real bad condition with the equipment. So that's and again, it's not testing them that I need that you guys should be looking for. It's whether or not they even exist. You two, I'll get to you. Have one first.
Yes. Is the bypass an actual code, or is it building practice manufacturer?
It's a manufacturer spec that I have to have a bypass for the zoning system to correctly operate. Exactly. On any non 100% communicating zone system. And again, that's going to be 99% of them out there right now.
So if we write about that,
correct. And when it comes to HVAC mechanics or HVAC equipment, what takes priority over code is going to be manufacturer spec. So you can always refer back to that. It's going to be what is per code or manufacturer spec, whatever's more, whatever's stronger. Yes.
Number one, does it look like a loop?
It can. It can look like I've seen them 1,000 ways. I've seen them go out 8, 9 feet, loop and go back. That's somebody trying to reduce noise. I've seen them go directly from the supply to the return with a damper in the middle. There's a bunch of different ways. It's a real quick connection. If you've got nothing connecting supply to return, you know they don't have a bypass in there.
Number two, if there's 3 zones, will you have 3 bypasses? Or
You're only going to ever have 1 bypass. And just on the mechanical side, this is what I'm looking for, that you guys don't have to, but it has to be sized correctly for the equipment. Because I have to have a big enough, it's called either a dump zone or a bypass, I have to have a big enough duct that will support the amount of airflow I need to go from the supply to the return when one zone's closed. I had a question over here.
So it's like this, guys. If you see the duct coming, you look at it, you think, this isn't beneficial because it comes out of supply, goes back to return. That's just kind of a mechanical thing in there. That's about that.
Thank you. Yes?
Confirm carrier requires that on all their systems?
It's not going to be carrier. I mean, if they're
As a
carrier.
manufacturer, as far as the
Yeah, it's the zoning systems are typically not made by the manufacturers of the equipment.
I understand that.
Oh.
But you have a carrier system. I know of at least 1 or 2 companies
Right.
that install that regularly over the last 2 or 3 years, and we have had multiple arguments over that bypass, and they say that it's not necessary.
And when we're going to come down to, and that's one thing that I do have to caution you of, equipment that's been installed in the past 2 or 3 years, like I've got a Linux equipment as well, the same thing, that I run a communicating zone system where I don't require a bypass. My machinery will slow the fan speed down. It'll slow the fan speed down and open up particular dampers and provide enough air to that zone. What we're looking at is older equipment that you're going to be putting in, anything beyond 5, 6 years. And if anything, you could note it. This is what's important. And this is back to your point. If you don't know the machinery well enough to know whether it's a communicating system or not, which I don't expect any of you to do because it is on the newer cutting technology, is to put it in your notes. System has a zone system, does not have a bypass that we can see, recommend HVAC mechanical contractor to inspect. And we can come in and confirm whether or not it does need one. But on zoning system, 99% of the systems out there need a bypass. And it's that big of a number. Like this one.
You didn't say require or have.
Okay, it requires a bypass. Sorry. When I say need, when it comes to my world, it's you need it. There's no question. I don't recommend it. You need it. It is required.
On all new construction, new implementation.
If it's a non-communicating zone system, yes. Again, we're back to, I know, but again, the HVAC, I'll get right to you guys. The HVAC world changes daily. It's just like cars. 2 years ago, we did not have, or 3 years ago, we did not have self-driving cars. We've got self-driving cars. Code, inspection, everything else is going to change on cars. going down and having your car inspected in the next 10 years, they're probably going to have inspected their parallel parking systems work correctly. This wasn't a thing 5 years ago. So we're constantly evolving. What we're trying to do is protect the homeowners. That's our job, is to go in and protect the homeowners from bad installations and to make recommendations for a mechanical company to confirm. This right here, there's no question right here there's a problem with this system. There's none. There's no way that that's a new enough system to not need a bypass on it, and there's no way that that thing not having platinum is proper.
No license mechanical contract to put it in.
Not necessarily. That's those fly-by-night guys that buy equipment and put it in out of the back of their truck, but buy the equipment online. Yes, sir.
So I did a warranty inspection, a home warranty inspection, so that we're buying it, we want to make sure it was okay. House a year old, I went up in the attic, which is where the whole system was, and there's computers all over that thing, and I had no idea what
Correct.
those things did.
And it's the same thing with my technicians. They never stop learning. I give training classes every single week. The reason being is because technology is constantly changing. If you don't keep up with the market, you're going to fall behind. An inspection today is not going to be the same inspection that was made 30 years ago. Not a chance. You all know this.
There was no bypass on that. I mean, it was just, looked like a regular system with some computers.
And again, because you don't know what you're looking at, you can't justify what the inspection is. Staying up with current equipment, staying up with currently what's on the market is what's going to help you out. It's what's going to put you ahead of the next person.
So would the thermostat give us any indicator that it's a zone system?
No.
So if the homeowner changes out the thermostat, is that going to be the system up?
It could potentially. Again, it all depends. We don't encourage homeowners to change out their own stats because of potential damage to the equipment they can do. My whole mission in this industry is to provide a quality service for my clients that help improve the homeowner's quality of life. My technicians are taught this. My technicians go into every home this way. I do not pay my technicians by making them generate revenue. I don't even pay them by revenue generated, which what you're talking about is companies that are very bad. I do not put them on a program to where they have to make generated revenue in order to get paid. All of my technicians are hourly, every last one of them. My guys are taught every single week how to protect the homeowners from their equipment, how to make sure the equipment is safe to operate. That's why you have me in front of you today. We are a quality company that stands behind our work. Okay? I will never rip off a homeowner or be shady with a client. I have 5 million people to work with in Atlanta. Do you know how much business that is? It's a whole lot easier to be truthful and honest with your clients than it ever will be to rip them off. That's just so you know who we are.
Amen.
Ductwork. All right. Active growth. This is just again for your knowledge, for what to talk to the homeowners about. If you see active growth on registers within a home, you'll see it a lot of times in basements. You'll see it around the registers, on the registers, possibly in the ductwork when you're looking at them. This is a very bad condition that we need to make sure we make our homeowners aware of. If we've got active growth, I am not certified to say it's mold. I call it biological growth. Okay? Unless it's sent to a lab, grown and tested, we don't know what it is. Unless you've got licensing to tell that homeowner exactly what it is, you're not allowed to say it. Mold is a very bad word in this industry, but it's also one that needs to be brought up. Biological growth is what I'm looking for.
Got a picture?
Sure. If you can flip over to the first one in that segment. I think it's the first one.
Those exhibit common locations where you find the.
This right here is a good example of biological growth on a register. This is a condition within the home. That means I've got a relative humidity inside that space above 55%. Anytime that I have relative humidity above 55%, I have a condition that will allow bacteria, algae, and mold to grow. Typically, you find this in basements. It means they've got no humidity control in the basement. It's just something that we need to make homeowners aware. This is something that should be brought up in reports as far as being found and needs to be looked at further. There's nothing you guys have to do with it. It just needs to be noted. We're going to have to do questions at some point. Take a pen, write down, and we'll go over them because we do have a little bit to go through. So this is just, again, if you're seeing this within a home, it just means that there's a problem within that home with too much moisture in the air. It could be a lot of things. It could be they have no dehumidification control. It could be a dehumidifier in the basement doesn't work. It could be the machinery is not working correctly. It's not naturally dehumidifying because it's in bad condition. It's just something to pay attention to look for. Plenums. Missing plenums. Again, we went over that. If you're missing plenums on your equipment, it really should be having plenums. If you run into a condition to where you're not seeing plenums installed on the equipment, it's a good idea, to talk about it, bring it up, just note it. Do you guys open the systems to see inside the ductwork at all?
No.
Okay.
Pull the blower door off and we'll take a look inside.
Okay. Again, I don't know how in depth you go, and I don't want to say anything that you guys should be doing when you're not. So I'll go off that. This is where I plan on pausing to ask any ductwork questions. Anything related to ductwork and not attacking HVAC? Let me get to him first.
One of the things I'm not sure when it's a problem, flexibility at
Okay.
strap.
Okay.
Quite often the strap will somewhat pinch the duct.
Correct.
At what point, because the support is
Sure.
on some bending.
Sure.
At what point is it restricting the circulation to this problem?
Sure, and that's a good question, because you'll find this in multiple areas. Not only will you see it to where it's being supported by duct strap in the attic, but you'll also see it at pinch points where it goes between joists in the ceiling. This is a condition that's restricting airflow through the system, which does damage it, which does cause poor airflow, which also causes rooms to not heat and cool like they're supposed to, because I'm limiting the CFM to those rooms. This is a condition that should be brought up to the homeowners. You're right, if it's pinched, and I'll tell you, if it's pinched 50%. I mean, honestly, if they're pinched, it shouldn't be pinched. I'm supposed to have a nice, clear opening through my ductwork, and what we can do on that is there's a couple of things. Depending on how long it's been pinched and how damaged the duct is, I can put in, either I can replace that duct or I can put in a metal sheath underneath it where they support it, which will allow that ductwork to be supported without pinching. This is it's a good point. We don't want pinched off ductwork because it does restrict airflow.
Related to this picture behind you, is this something that you see that needs to be called out more, or is it something that y'all get called on to look at? Because, I mean, I've gone out and seen this being
Windows.
it's just dust built up on the windows.
Potentially, what's going on in this picture is this. All of this stuff on here is biological growth, and what happened was there was dust on this registry. This is dust. Dust has gotten moist, and usually it's due to high humidity levels. Inside of dust is all sorts of stuff that you wouldn't believe. Anything from pet dander to human skin flakes to pollen to spores to mold spores to there's everything you can imagine in a particulate of dust. And what happens is when the conditions get right and there's enough moisture in the air, it allows it to grow. And when it grows, what I'm looking for is a condition. This tells me there's too much moisture. There's dust in everybody's house. There's always dust in people's house. So for it to grow like this means that there's a moisture issue within that home. You say it's by a window, there's a good possibility that window's leaking air, it's got bad seals around it, it could come back to the window. And not necessarily the HVAC system, but also it means usually they probably don't have a dehumidification control within the basement.
Another place, I looked in my bin, I saw that in a double hung window in a teenage room, it was smoking.
Oh, no.
And went up about 2 foot into the duct, I had to replace that.
That whole section of duct?
Was molded.
Yeah.
From them keeping that window.
And that's exactly what it was, is that window being open was allowing humidity to come in, and the dust inside that ductwork started growing. So that's a condition, that's a problem. It happened to be your kid that was causing the problem, but it's a problem within the home with too much moisture.
Can you kind of give us a brief outline of what good ductwork installation looks like? Because what we normally see, you talk about a plenum, is every supply duct coming out of that plenum and going, looks like an octopus. Should you have a main trunk line go out of the plenum and then
this is
branch
going to be
off?
something that you're not going to be able to fix. It's Georgia. My background is commercial installation originally when I started off in this trade in a different state. And my job was to build and design duct, as part of my job was to build and design ductwork to meet standards of commercial. I had to have metal duct that can't have no more than 6 foot of flex in any single system. I had to have dampers on every single room. I had to be able to have a third party come out and dial in my ductwork down to the CFM per room. Okay? Welcome to Georgia. We have spider boxes here. It is an out of control situation that as a mechanical contractor I can't fix. What you're looking for is not duct design, but just duct problems, ducts that are falling on. Matter of fact, I have one. Can you flip through a couple? This right here is light coming through where they had attached the ductwork. I had them shine a flashlight in just so you can see. I've got light coming through right here. This is a return ductwork that is just sucking in 150-degree attic air constantly. So we're looking for unsealed ductwork. Can you continue on a few more? Keep going. Keep going. We'll skip this one. Keep going. Okay, here. This ductwork right here, this is a supply plenum. This ductwork is pulled off about 4 inches at the top right here. This is what we're looking for. As inspectors, we're looking for this. This is an obvious mechanical issue that the homeowner is losing not only air into the attic, but they're dumping their electricity, their power right through that machine. This is a very, very bad problem within that home, and it's easily seen and caught, but we just have to know to look for it. That's what we're doing. And I know there's a lot of new guys to the trade. This is something that you look for is disconnected duct that's not sealed up real well.
You go to the attic, you feel a cool breeze.
Yeah, you got a problem.
You have to have M1 label listed, M1AV tape, mastic, that kind of thing. No zip ties, they okay?
We have ties within the industry that are designed for ductwork. You can't see it's actually on this, but it's been masticed over. This actual flex duct has been held on with a zip tie right here, but it's a commercial zip tie designed specifically for ductwork. Your duct should be mastic around the plenum where they attach to it. We've got a collar that we put into the plenum. We attach our ductwork to it with a zip tie, and then we tape and mastic around it. And again, it's not gray duct tape. That is not. That's not.
The red writing tape, AV, 181AV, guys.
Yeah, correct. This right here happens to be, tape used for my industry, but you'll find tape out there that's not listed too. It doesn't have the red numbers, unfortunately.
So if you don't have any writing, it's okay?
That one goes back and forth. You're not every tape on there is supposed to be listed for its heat, for the heat, the adhesive it can withstand for heat and cooling. But I see a lot out there that is designed by mechanical companies that is used in the industry that doesn't have the lettering on it. And going through every single job and trying to find the lettering on tape is not something you guys need to be doing.
Yeah, but if we're going through a home, even a new home, and we see naked tape, there's no writing, I'm gonna call it, guys.
That on a new construction, yes. On a new construction, this is a retrofit. But new construction, yes. But if we're talking about inspections going back 15, 20 years, if I've got ductwork that's sealed up real well, again, I'm protecting the homeowner, is what I'm doing. I'm protecting the new buyers of the home, is what I'm primarily looking for at this point. On new construction is a little bit different. If you're doing a new construction inspection and they're not installing the stuff up to code, oh yeah, by all means, get on them. Because that's very important, because those codes are there for a reason. And the reason for that particular code is so that way they don't put in a cheap tape that falls off when that attic gets 150 degrees.
Use the gaps like you had over that last picture.
Yeah, exactly. The tape will unadhere in extreme cold or extreme heat conditions, so they make them labeled now, which is why it should be done.
So what's it referred to as, red labeled?
Yeah, this right here, I can identify what this tape is its adhesive temperatures are by that number right there. It is.
In a new system.
Yes.
It could be installed in a 50-year-old house or new construction. But in a new system, should the ductwork be taped and masted together, or can it just be taped with the UL rated tape, or can it be just masted?
Best practice is it should be mastic. By code, it can probably be just taped. That's something that we'd have to look further into.
Well, no,
Yeah.
DCA did an amendment that said, without exception, all HVAC joints and sections should be covered with mastic, minimum 2 millimeters thick.
Which is like thick as a nickel, and you hear a lot of times, thick as a nickel. You know, the mastic's got to be thick as a nickel.
Yeah, so you shouldn't be
Thank you
able
for
to
that.
even read the red lettering.
Yes.
Yes. Doing a house, I did a Victorian the other day, good HVAC system, big delta between the wet, moist crawl space, flex stuck in there. It's turning colors. You can see the fibers kind of going white. And in the past, I found literally gallons of water that'll condense because you got too big a delta and the cold air sits down there. When the outer lining kind of fades from silver to kind of white, you can see the fibers through there. Is that the duct getting wet? Is that the insulation failing, or is that just kind of a normal thing? Does that normally
On
happen?
aging duct wrap is what you're talking about, is the old style wrap. I've seen them age that way in just about any condition. They seem to deteriorate over time when you've got an element involved, whether it be heat, moisture, cooling. They seem to degenerate that way.
So that's not necessarily a moisture problem within the ducts.
No, and it's typically going to be, it's going to be the environment it's in. And it's going to be an unconditioned space, which is going to cause that.
So it's nothing.
You're going to lose R value. As a mechanical contractor, I can advise the customer to rewrap the ductwork to help improve the R value for less heat loss and cooling loss throughout the year. But it's not something I'm going to go after as something to protect the homeowner.
It's not an indication of a biological growth.
No, sir. You will see in unconditioned space that has high humidity, though, you will see this growth you will see the growth on the external part of the ductwork. You will see it. Doesn't mean it's in the ductwork, it's on the outside. It means moisture is condensing on the outside of the ductwork because of the environment it's in. Usually an unconditioned space, crawl space, with high humidity. And a lot of times you'll have plumbing leaks.
AC at 70 or something.
Yeah, well, you'll have plumbing leaks or foundation leaks that allow too much moisture underneath the house, which gives it an environment to be above 55% relative humidity, which means dust grows, turn algae, mold, and bacteria, all grow at that environment.
Okay, and this is a prime example. On new construction, we see where the duct insulation is sealed, but not necessarily the duct. Is it not more important to seal the duct and not the insulation?
Not too sure I know.
Or can you just seal on this one right here, the duct is not sealed where actually, well, it doesn't look like it was sealed where it attaches to the plenum.
It was at one point.
Insulation has mastic on it.
Yeah, this right here is the mastic that they had put on it when this was installed. They had actually taped it on and masticed the thing. I suspect what happened on this job was too much weight out here, non-supported, and actually pulled this ductwork down and separated it from the plenum. These little tabs right here, these tabs are straight, which means more than likely there was a pretty tremendous force due to weight and time that had pulled the ductwork down. It just wasn't properly supported. It was actually, from what I can see of this picture, it was probably actually installed rather well. It's just that's a very big duct with a lot of weight on it.
But if the mastic is around the insulation, you can't really verify whether the duct is sealed or not.
If that, you'll see well, you can see the mastic will separate when you have a leak. If you go back to 2 pictures, I believe, or back to that plenum one, I'll tell you.
He's talking about the inner black strap.
You'll never be able to tell. You should never see that inner black.
But if you do, does that have to be sealed, or it's just sealing the outer insulation adequate?
Yeah, there's going to be an inner sheath.
That's right.
That inner
You're gonna
sheath.
strap it.
That-
You're going to strap it. Does that have to be taped or mastic?
That inner sheath should only be strapped. And then you pull the outer jacketed insulation over that, and that it gets strapped, and then that gets mastic and taped. The inner sheath I don't want taped.
Okay.
Or mastic.
That answers my question.
Okay, I'm sorry. There's a lot to it. Okay.
Please wrap it up. Outside air, we've noticed newer systems where they're pulling outside air off of a roof. Seems to have a backflow preventer on that roof mounted vent. Is that correct? Or are they using the wrong roof mounted vent?
Backflow preventer on a fresh air vent?
Yeah, fresh air.
That defeats the purpose of it.
All the time. Lennar is doing it, EA Homes is doing it, they're not taking the backflow off.
Yeah, that defeats the purpose of having fresh air brought into the home. No, I'd pull it from the eave, and I wouldn't pull it from the roof for one. That'd be better practice, but
They're using kitchen exhaust vents, and they're putting them on the roof.
I'd look into that, because if that vent's shut all the time, there's no point in having fresh air intake. Actually, what we prefer to do when we're installing is put a motorized damper that will only allow fresh air to come in when the outdoor humidity and outdoor heat and humidity are low enough to pull fresh air into that home without increasing the sensible load in the house.
And under that same vein, is it recommended to have those filtered?
No, the HVAC system will filter it. It'll always be before the filter. That takes care of itself. Was there any other ducts?
Kind of like a duct. The filter door, does that have to be totally sealed?
It's supposed to be.
It is.
Yes, because you're pulling in outside air at that point. The filter racks that we install, you have to close it and turn a handle, and it's got a seal around it. Yeah, that should be sealed up. Unfortunately, by definition, you can put the little metal doors that slide onto there, and it's sealed, which will pass an inspection. But if you're missing one altogether, that needs to be noted. Because you'll see where they have the opening where the filter goes in. Always note when they don't have a door on that, because that should be taken care of any kind.
Central return air systems and lack of undercut doors in the bedrooms?
Okay, so what he's referring to is when a home has one single return in on a floor, and we have supply air into all the bedrooms. This creates a condition. You have to either A, have a return into each and every room on that floor for proper airflow, or you have to have the doors undercut at least 3/4 of an inch above like thick carpet, or you can put in transfer drills through the walls and doors to transfer the air from the room to the main area. Is it code? Is it a problem? That's the question. As far as I know, it's not.
Well, you gotta have return air. If you see dust around the door frame, guys, it's not proper air.
Correct. It's a best practices. There should definitely be something. The door should be undercut at a minimum. At a minimum, I like to see a 3/4 inch undercut on a door that only has one return to it. Because what'll happen is when that system kicks on, it'll slam the doors, for one. It'll slam the doors within the home because it creates a negative static pressure in that area that can't be compensated for. And the other thing it'll do is it'll not allow enough air to get out of those rooms back to the central system.
A lot of times we see carpet around those floors dark. You get back in every day, you're still gonna get dark carpet around the baseboards, and you get door frames that are dirty and things.
Correct. So again, that would be more of a recommendation. I don't believe you're going to have a code issue, are you?
Well, it's like, the return got to have so many cubic square inches of return air.
Correct, but you have a door that can be left open. That's where it falls into a little bit of a gray area.
Right, on that same vein, Southgate did a study on that, says if you close that door, the ideal cubic inches would be 14-inch cut under that door.
14-inch cut, are you serious? Wow. Oh my goodness. Well, transfer drills. Transfer drills. All right, let's talk a little bit about drain lines. Can you go to that drain line section? Drain lines. Drain lines are fun. Drain lines by definition have to have a 1/4 inch per foot slope minimum. And this is one thing that we don't see in Georgia ever. So we don't have, we're supposed to maintain a 1/4 inch per foot slope minimum, and the reason for, and this is where the technical comes in, guys, this is what I'm here for. You can quote code all day long, but until you know what it's for, you don't know how to properly advise your client, because they'll ask why, they'll think it's nonsense, and your recommendations go out the window. If you don't know the whys behind why the codes are there, why we're recommending them, nobody's going to listen to you, nobody's going to do the recommendations, and then the next time they're not going to tell their neighbors that you caught something that nobody else did because you don't have the backing. So the reason that we maintain a 1/4 inch per foot slope minimum is so the drain lines don't back up. What happens when we have anything above 55% relative humidity? You're going to have algae, mold, and bacteria growth. I'll state this a million times. Drain lines back up. So in order to prevent that from happening, we slope the drain so it never stops moving when it drains. So a lot of homes are built to where the drain line will come out of the HVAC system, go to the ceiling, and run 20 feet across the attic to an exit point that goes down the house. I have cleared these drain lines out with about 2 pounds of sludge out of these units. When we come into a home and we see this, or when we're installing new systems, we change all this. It should be changed. That's per spec. That needs to be changed. And it gets missed on a lot of reports when you guys could be, you could be letting your homeowners know that this is something that should be taken care of. To help maintain the flow of condensate from the system, to prevent algae, mold, bacteria growth within the drain line that will stop up the system and potentially cause ceiling damage if the water protection devices don't stop the water. I've seen $3,000 ceilings drop because of plugged up drain lines. The entire upper floor ceilings will fall through when the drywall gets wet. That's insulation, drywall, massive damage to a home due to drain lines. It's a very big problem in Georgia that we're doing everything we can, one home at a time, to rectify. We also see other problems with drain lines, and one is safety switches. All new construction, all new homes should have safety switches in every single one of the upstairs systems. They need to have some sort of device that will shut the equipment off if water is detected on the upstairs system. Is it for main levels as well, or just upstairs? Anybody know?
Toward that end, systems in basements a lot of times do not have overflow fans. You have it in that as well.
Correct. We recommend them on every system out there is to have an overflow safety device installed. Some of them is with condensate pumps that we find that a lot of condensate pumps, when they're installed, never wired in the safety devices. You'll see 2 wires hanging off the side of the condensate pump. Half the time you see them, they're not wired in. It means that safety, if that pump ever fails, the safety inside that pump won't stop the system off. It'll flood out the basements, it'll flood out attics, it'll flood out. Can we jot these down and then we'll go back over these? So having safety devices in upstairs systems is a must. Period, dot, dash. If you see an upstairs attic system that does not have some sort of device that shuts the equipment off, a safety float switch, an inline safety switch, this needs to be noted. And what we're doing is we're protecting the homeowner when that drain line plugs up. Notice I didn't say if, it's when. When the drain line plugs up. The outside drain could get covered by mud. The outside drain, we usually find squirrels will get up in the attic and drop nuts down the drain line. Is that preventable? No. There's nothing I can do in this world to prevent animal damage, to prevent floods, to prevent anything else. So, assuming the drain lines are going to plug up, just assume it because it will happen over that home's history, we need to have a device that will shut the equipment off so it'll quit producing water. If it doesn't, what will happen is the homeowners will go on vacation. That's when this happens. They'll come home to an entire ceiling in their upstairs second story of their house completely dropped onto their floor. And we see it constantly. I have a direct number to a water reclamation company that gets a lot of business from me. Okay? How many of you as homeowners have gone through a water reclamation process? Okay? It's not fun. It's expensive. You've got people tromping around your home. You've got painters coming in. You've got drywall guys coming in. You're being all but evicted from your house. It is an absolute nightmare to have a water reclamation company come in. You're potentially removing walls, floors, paintings. You're losing your valuables inside of your house will get damaged. Depending on how long you're away from the home, your pictures will get ruined. I mean, it's a dramatic thing to happen. And in Atlanta, we have it happen constantly because of drain line issues. So drain line issues is something that you want to pay attention to. We also find that that traps are misunderstood. And actually, can we pull up a picture of a trap so that way everybody's on the same page with this? Okay, this is a trap. Okay, this is a trap in an HVAC system. And these are so misunderstood on the market, even amongst HVAC personnel. Don't get me wrong, well, the things that I'm talking to you guys about are the same things I talk to my technicians about. Okay? This trap right here, the design behind a trap on an HVAC system is so that I have what's called water weight. This is water weight right here. This water that holds, I need 3 inches of water weight on this system to prevent water from going back into the system under negative static pressure. Bunch of mumbo jumbo. So what that means is this. I don't need a trap on a standard AC system that has positive air going through it. A standard split air conditioning system does not need a trap in it. And a lot of reports that we find, people are saying that they do, and you know, they don't. If I've got positive pressure, if I've got the drain line on the positive side of the fan, I don't need it. I wish I had a drawing of the system. So, heat pump air handlers. Everybody knows what a heat pump air handler is, for the most part? Okay, the drain line's right here, the fan's right here, okay, the supply duct's up here. With the drain line being on this side of the fan, there's negative static pressure inside of that cabinet. It means that fan's drawing air. It's also going to draw air up this drain line. And what happens is, as this thing tries to drain, that fan's going to pull the water back up. Okay? It won't let that system drain water. It'll pull it back into the cabinet. It'll cause water damage to the home. It'll cause water damage to the equipment. That's what traps are for. That's why they're installed, is because this particular drain line on this system, this is a heat pump air handler, has negative static pressure into it and it's drawing water back up into the system and it won't allow it to drain. When I put 3 inches of water weight right here, that fan can't overpower the water weight. It means it won't draw the air through, which means it'll allow the water to drain. Traps. Can we go to another picture of a trap? This trap right here is something to look for. This is what is missed. You can zoom out just a bit because I actually need the other way. This right here completely defeats the purpose of this trap. I need 3 inches of water weight right here. If I put this vent right here, this clean out right here, and I don't cap it, that fan's just going to suck water right back into here. It will not allow this system to drain water. Okay? You can have a clean out. We recommend a clean out. This is going to grow algae, mold, and bacteria. We want it cleaned out, but I need it capped. An uncapped trap. An uncapped clean out before a trap defeats the purpose of the trap. Okay? That has to be capped. We need somebody to come in and get this fixed because this is going to be a problem. This is a problem. They put 2 clean outs, one right after the other. They probably put that one in first, realized the trap needed to be cleaned out, put in a second one, and never put a cap on the thing. This one right here does not need to be capped because it's on the other side of the trap. Okay? Anything before the trap, it has to have a cap on it. Anything after, I don't care about. What is important though is it goes above the drain pan inside the air handler. This T right here has to be higher than the drain pan inside the air handler. If this drain line plugged up, and this was wide open right here, it's going to drain out right here and damage their ceiling. If this is extended above the drain pan, it's going to back up into here, and hit this safety switch and shut that system off. We're going to have to hold questions, guys, or we'll never get through this. This right here is a safety device within the system. This overflow pan down here also requires a safety switch. Okay? We need to protect these homes. This pan is always going to have a safety switch in it. And I'll even tell you why. If, for whatever reason, this coil freezes over and starts draining down inside this pan without setting off the switch, you're going to have ceiling damage. Pans need to have switches in them.
What about a drain?
I've got that on here as well. We'll get to that here in just a second. Matter of fact, we'll go to it right now since we're talking about overflow drain pans. Okay. Do we have another? Let's switch through a couple pictures. Okay, here we go. So here's an overflow drain pan right here that we've got all sorts of issues. Did I tell you about Georgia's drain lines that run flat along the ceiling? There's not a 1/4 inch per foot slope on that drain line once it gets out of that unit. It goes directly to the ceiling, runs 20 feet across the ceiling, and that's bad. Overflow drain pans. When I'm doing a new installation, just so you guys are aware how we operate, I do not ever run an overflow drain line, ever. I put in a brand new pan underneath these machines, I put a cap right here, and I put a safety switch in this system. Okay? The reason being is this. These things, it's not the code. There's a code that can have an overflow drain line. I probably shouldn't tell you guys about this. You can have an overflow drain line. I can't test it without flooding the system out. And half the time, because they're so old, they tend to leak at the pan and ruin the ceilings anyways. I hate them. Absolutely hate them. So you can have these overflow lines in here. You should still have a switch. What happens if this guy gets plugged up with insulation, that blown-in insulation? You guys see these secondary pans full of? Anybody been in an attic has seen it. What happens as soon as this thing fills with water, it plugs up the secondary line, floods out the ceiling. Always, always, always. No matter what home you go into, you see a pan, thing needs a switch. It needs a switch.
Your way to test those things work.
I mean, you can have the system running, you can lift it, and it should shut the system off. However, depending on how they wired it, it might just shut the compressor off. And the problem is, as soon as you let it go, it's going to start that compressor right back up and short cycle it. Don't touch it. I'm sorry to say, but yeah. And I'm giving you the reasoning behind it. It's not just telling you no, but giving you the reason behind it. Will cause damage to that equipment if we just trip that thing and let it go. Depending on how it's wired in, it could burn up the compressor pretty quick.
Real quick, along these lines, just so I understand, if a system has an overflow pan and has a drain line going down to the outside,
Correct?
by current modern code, is that acceptable?
Yes. You still have to have a switch in it though.
Oh, you do have to have a switch.
Oh yeah. You've got to have a switch in this thing. Don't ever get away from a switch. And you can reference, I'll give you my phone number, and you have anybody call me that they want and tell me a switch is not needed in an attic.
I mean, is it in Fred someplace? We run into that a lot.
Yeah. I'm not sure. Yeah, I'm not too sure where I would find it for.
We break things up, we've got to be able
To back it. Yeah, I understand.
So that's what I'm trying to get to understand. Is the switch, I know you would not sell it without it, I understand.
Correct.
But is the manufacturer specified that it has?
Does anybody have current building codes on new installation of switches in ag that we can reference to?
Does anybody know it? I mean, does anybody know?
That'll be looked up. It is. Any new system installed under mechanical code has to have a safety switch to shut off the system. I don't know the number offhand. Okay. As soon as we get through the drain lines bit, I'll let y'all, you restless people, go take a break, okay? But we got a little bit to go here. Foundations. Can we switch pictures? Keep going. Here we go. So, condensate drain lines draining next to the foundation. Okay, we need to not do that. That's going to drain back into the home. It's going to corrupt the foundation. It's going to cause, depending on what's going on, it could cause siding rot here. It could cause wood rot down here. It can get into this foundation and crack it. There's a lot of reasons that we don't want to drain.
It attracts termites.
It attracts termites. Good call. So when you see something like this, a condition like this, where the drain line, you can see the staining. This is actually eating the surface of the concrete out. Okay? When you see a condensate drain that is draining right next to a foundation, it's something that needs to be fixed. We need to drain the moisture away from the home. I think maybe the next one might show what we did actually. I have to keep going. Keep going. Keep going. Boy, keep going. Drain lines are a big issue, guys. Keep going. Keep going.
Is that legal?
Hey, wait, we'll get to that. We'll get to that. I know, it's a lot. Keep going with them.
That's the end of it.
Oh, well then hit back to we might have did it. We'll see that house again. Here we go. Here we go. This is that same house. Here's the drains that we're draining across this right here. We put in PVC, brought it up underneath the door, brought it out to here. We're draining it out here away from the home again. Okay. It's something that we do for a living. It's something mechanical contractors can fix. So make sure that we're draining the condensation away from the home. Okay. You'll see broken drain lines, loose fittings. Get it. Best practices. You guys are going to kill me with codes. I'm not a code inspector. I'm sorry. So that's your guys' department. I'm going to tell you all day long. Yes.
Does that picture have to have a 1/4 inch slope as well?
It's supposed to. I couldn't maintain it underneath the door though. I couldn't maintain it. It should. Any drain line out there should have a 1/4 inch per foot slope minimum. Do you guys actually want to take a break now? Yes. Okay. I don't want to keep you. Let's what time is it? We got 10. Let's convene back at. Can you still hear me? Is this still working? Okay. I didn't ask him to say that. Just for reference, I won't read it because actually I've got to be off this by 11, so my plumbing manager can talk to you guys. As far as condensate drains, code section 307.2.3. We'll talk about auxiliary drain lines as well as safety switches for the systems. So if you get a chance, go ahead and take a look through that. I have a whole lot more material than it looks like I'm going to be able to properly present, so we're going to go through a little bit of this. Can I have you flip to the pictures and I'll just kind of talk on some of these things that we're finding. This right here was an obvious issue. This is a secondary drain line on an evaporator coil that didn't have a plug in it. These guys definitely need to either have a plug or a safety device or tie it into something else. It's for an evaporator coil for an AC system. We can go to the next one. This guy right here, this is actually a bad trap. I don't have enough slope coming out of this thing. The drain pan's right here, but you guys won't be much responsible for that. When you see something really odd, it doesn't hurt to have us look into it. Go ahead to the next one. Double track, go ahead. Flat drain line, go ahead. This one again. This is the primary drain line for a system. It comes down and it runs flat from this point on out of the facility. Here's your secondary drain pan line that we were talking about a minute ago. According to code, if you have one of these, you don't have to have a safety switch, but again, best practices, if you've got a pan, there's no reason to tell a homeowner that they don't need to have a safety switch in that attic, because this drain line will get plugged up real bad. The last one that happened with us last week, that actually the homeowner tried calling us out on. We did an inspection on a home for a system, regular routine maintenance. There's no way for me to test this line at all. There's none. I can't do anything with it besides flood this pan out with water to hope that this pan holds water for one, it's sloped properly for two, and the seal around this joint is good for three. On a preventive maintenance on a system, I'm flushing and cleaning primary drain lines, letting the homeowner know about problems within the home. Had a homeowner that didn't want to get resolved the low refrigerant issue. They went out of town, system froze over, flooded out this pan. It leaked water around this joint right here because the seal was bad. Okay? Flooded out their ceiling, $2,000 in damage to their ceiling because of this joint. Okay? Nothing I could do about it. So again, I highly recommend having overflow safety switches installed in these guys to help prevent damage to the home. Go ahead to the next one. Yes.
Question. Just like you said, if you have the safety, if it's plugged up and you have the safety switch, it's going to turn the system down.
Shut up.
If for some reason the coils were froze up and the system shuts down, it's still going to overflow, right?
No. The system won't come back on as long as that pan's full of water with the safety switch tripped. Yeah, it might melt and leak a half a gallon of water versus continuously running and flooding 30,000 gallons of water. Okay. Drain line, go ahead, next one. We talked about this one away from the foundation. This one is a problem right here. It's hard to see, I'm sorry. These overflow pans right here, if you can see this overflow pan is for one, too small, and for two, mispositioned. This is an evaporator coil behind here that attaches to a furnace that's horizontal in the attic. This pan does not cover where this system's going to leak when it has down, when the water plugs up. This is a useless pan because it's just going to run on the ceiling. They have to have a properly sized overflow pan underneath the equipment to catch all of the water when that system leaks. This is another critical one. You can have a pan on there all day long. If it's not big enough to cover, it needs to be addressed. I got a couple others like this, I think. Go ahead. Okay, perfect example. Brand new install one that we found. This little itty bitty pan right here. Don't get me wrong, it's great. They got a pan in there. Safety switch, it's plugged up right here. Overflow's not used. This is absolutely great. But it doesn't cover where the system's going to leak. It's absolutely irrelevant. This system plugs up, water's going to leak out to this joint right here, flood this ceiling, take out this electrical, and damage that home. This is a pretty easy, hey, there's a problem here. You know, the resolution is not for you, it's for us. This is a pretty big resolution. We have to jack that unit up, put in a big 4-foot pan underneath the thing. Don't worry about it. That's on us to fix. Just identifying this as a potential issue in the future is what we're looking for when we're doing a home inspection. Next one. Rotted out overflow pans. This is another one. You see this mess right here? All of this blown in insulation. Tell me if I have an overflow hooked up to that thing, it's going to drain. Okay? This is what we see when we come into homes to service equipment. Is this kind of stuff. For one, they've had a water issue out there because of all that rust in that pan. There's an ongoing problem with that system that needs to be addressed. For two, they've got blown in insulation in that pan. For three, there's no overflow safety switch on this thing. What else is there? There's a picture. It's a hot mess. I would advise getting somebody out there on this equipment right away. Next one. This is a classic one that we see all the time, and it's a big no-no. This is a drain line that's tied into a vent stack for plumbing.
Oh, great.
You guys are going to see this all around Atlanta, all over the place. Some genius company couldn't figure out a way to drain the unit outside, so they decided to tie into the vent stack. Okay? I'm going to tell you, as a company policy, we will never tie into a vent stack. It's what will end up happening. The reason you don't tie into plumbing vent stacks, methane gas will come back up the vent stack and enter in through the drain line into the home. Okay? Now, you may say, well, what if they have a trap? What if they trap this right here? Wouldn't that make it to code? No, it will not. That trap will dry out over the winter when that air conditioning is not running. You're going to get methane gas back into that house, into the attic. Okay? Well, what if I install a wet trap? Wet trap is a trap that constantly has water supplied to it, that's on a float, that will constantly fill itself every time it gets dry. We've just introduced water into an attic in a potentially freezing condition. No. Don't tie in the vent stacks. You can keep going. I got a couple more vent stacks, which are great.
Not only that, it pulls the odor into your AC system.
Yeah. Here's another one. Here's another company cut a vent stack. This is one that we found. We found a whole subdivision like this, guys. An entire subdivision, new development was like this. This is a vent stack that was terminated into the attic. They ran the 3/4 drain line over to a 1.5-inch vent stack. Do you know what happened? This is what happened. Customer calls us up, said they had water coming through their ceiling. That vent stack plugged up between there and the sink below. It backed up. There's no seal here. That water came right out of there, went right down their walls. Do you know how much water was dumped into that house before it came out on their ceiling? That wall cavity between the floors was full of water. Guess what happens when you fill a wall cavity full of water? Algae, mold, bacteria growth. That whole wall has to come down now. Because of conditions like this. This house, when it was built, this whole community, when it was built, this should have been caught. This home was inspected. These are 3-year-old homes. These homes were inspected. This is what was missed. It's very important that we make sure we don't tie into vent stacks of any kind. Okay? It's very important. What else we got? So, someone thought it'd be a good idea to tie in a condensate pump into this vent stack and put in a loop right here. That's kind of a trap. And seal it up right here. This ain't going to fly. If you see stuff like this, it's not going to fly. We do not need to tie HVAC into vent stacks ever.
What about high efficiency furnaces tying into like a laundry box?
You can by code, but you've got to be careful with that because also that laundry box has to be able to support that line coming into it. That box has to be designed for that line. So yes, they have specific applications for that, but again, it has to be. You can't drill a hole in the side of a washer box and stuff a pipe in there and be good. That's not good. You can't. It has to be able to shop. Yeah, no, you can't do that. High efficiency furnaces. As a company policy, we don't put them in attics because it drains all winter in a potentially freezing condition. We should not be having water in attics, guys, over the winter. I don't know code on that or not. That I can't tell you. I'm just telling you as a practice for us, we don't do it. What else have we got up here?
That's the end.
That's the end
of this particular one.
All right. Let's go over to 3. Gas lines. And I don't mean to push this through too quick, but I do want to show you guys quite a bit of stuff that we find every day that needs to be caught. And it's all simple stuff that's easy to see. This is a flexible gas line that enters into a furnace through this wall right here. We can't have this on furnaces. If you guys see this, this is a big no-no. I have to have black iron coming from this gas valve, coming through this gas valve and exiting the furnace to where then I can go over to a flexible gas line once it exits the furnace. The reason behind this is, again, why do we have codes? To protect the clients. You see this line right here that goes through this metal wall? This machine vibrates. I have got a motor inside of this thing that turns at a couple of thousand RPM. Guess what happens over time? It starts to vibrate over time. Bearings go bad. Motors get out of balance. It vibrates. What happens when I have a very thin-walled flexible gas line against the hard metal cabinets is vibrating? It's going to rub through. It's going to create a leak. That house is going to explode when that furnace turns on. What's that? Okay, he'll cover that when we're talking about that. So this is a big no-no. Just if you guys see flexible gas line going into this furnace, we can't have that at all. It has to be black iron coming out, exiting the furnace. Next one. Yes. No. No. Even an old unit. We need we need to get black iron run through that machine. You see it all the time. This guy, somebody was a genius here and stuck insulation for a pipe right here. It's irrelevant. What happens with rubber material over time, with plastic material over time, it wears out, it breaks down. It's going to get the same condition that it was even without there. So no, it'll dry out, it'll rot. No, we just have to have black iron going through that firewall. Gas company will shut them down in a heartbeat if that's found. That's a big no-no. What else we got?
With the sediment trap.
What's that?
With the sediment trap.
Sediment traps are in here as well. Same thing, this is the flexible gas line going into that furnace on that job. Go ahead and go to the next one. This one's just a mess. We got drain lines that run completely flat across the ceiling. We've got, what else? This one right here, this overflow dumps into this pan down here, which has a flat drain line that runs across here. It's just a mess. But that one's irrelevant. What's the next one? Here we go. This one is one that we're finding more and more and more and more common. We have to have a 3-foot clearance from that gas meter around my condensers. 3 foot. And what happens is you guys are up against a whole bunch of fly-by-night mechanics out there that are installing air conditioners out of the back of their truck that don't know code from their hand from anything. This cannot be like this. I charge my clients extra to do it on site. When I'm installing new equipment, I relocate that condenser at least 3 feet away from that unit. Again, this needs to be caught on inspections. I got several of these ones. Go ahead and flip through some more. I need 3 foot away. Actually, 2 problems with this one. For one, I'm 3 feet within. For 2, this drain line drains literally on the foundation. For 3, this unit should be maintaining at least 1 foot minimum on the backside of that coil for airflow through that unit. This is an air-cooled condenser. The only way for me to pull the heat out of the refrigerant is to have airflow through that coil, just like your car radiators. I have to have air transfer through to remove the heat from the refrigerant so I can cool the house.
Isn't that a manufacturer specification?
Manufacturer specification. Most of them require 24 inches minimum spacing between units, 48 inches above the units, and at least 12 inches on one side. Some of the machines are a little bit, I might get it down to 8, depending on the manufacturer, but all of them require minimum spacing off that back coil. All of them do.
Why the difference between the gas meters?
That's a gas. That's a gas code right there. Yeah, that's a gas code.
Is that all gas line?
Yeah, the regulator on these guys dump gas, and I've got a 230 volt appliance right here that's going to arc at some point in its life. All right, what else we got? Hey, another gas meter. So, again, we find these quite a bit. What else we got? All right, what else we got? The point of this is to be able to quickly see, to know what you're looking at. I'm just giving you some pointers. Some people in here haven't seen this kind of stuff before. Here's another one. Here's a T. Okay. Gas lines. I have to have a sediment trap before my gas appliance. My furnaces have to have a sediment trap in here. This one does not pass code. That's cute. It looks nice. The whole reason that I have a sediment trap in place is to catch any debris that's coming down the gas lines and catch it before it gets to my gas valves, plugs up the gas valve, damages the orifices, and supposedly if there's any kind of moisture in the line, but it's mostly for debris. So in this case, by code, I have to have a deadheaded gas line. Deadheaded means my gas comes out, it hits a wall, sediment falls out, clean gas continues up. In this case, I've got gas that would come up this line, skip right over this sediment trap, and continue on into the machine. I got some more of these. So when you see a gas line that is not deadheaded, this is the same one. Go ahead to the next one. I think it's the same one. It looks like it's the code, but it's not. Again, I've got black iron coming out of the machine. That's the code. Flexible gas line, that's fine. This trap has to be located as close to the machine as possible. But it's not the code because it's not deadheaded. I hope I have one that is. Go ahead, the next one. No. Apparently I just got a bunch that aren't. I've got sediment trap, but the gas line's not deadheaded. In order for me to be able to deadhead a gas line, the gas has to come to here, stop, and continue on while the sediment falls out. This will just pass right over.
So you have to use the T and it goes up.
Yeah, if I turn this T, this is a T right here. If I turn this T 90 degrees, I now have a gas line coming up, gas line coming down with the source of the gas coming into it. And then a gas line comes over. This is where I put a T, put a flexible gas line in over here and continue on. That T needs to be turned.
You know, that is not in the code book.
It's in, it is.
It's deadheaded.
Yes.
9-degree turn.
I have to have a 3-inch minimum sediment trap. That gas line has to be deadheaded. Coming from the supply, it has to be located as close to the appliance as I can get it. Yes, sir.
Shouldn't there also be a flexible line out there?
No, I don't have to have a flexible gas line at all in the machine, as long as I've got a sediment trap. What else do we got up here?
That's all.
That's all? Yeah, a good point. I do have to have a union though. If it's hard pipe, if it is hard pipe, then I don't have a flexible connection. I do have to have a union installed. I do.
What's your time of practice?
As far as when we're doing a new installation, is bringing the gas line up to the machine, deadheading it, flexible gas line over to a hard pipe. I'll usually use a 12 or 14-inch flexible gas connector. Can we go to number 4, please? Flue pipe. Why are codes enforced? To protect our homeowners. This is one of the biggest one in the industry, guys. This is one that all of us miss, both as technicians, as inspectors. This one's extreme. The reason that we have so many codes for flue pipe gassing is because people will die within the home. And it happens to elderly, it happens to children, most susceptible. Okay? But anybody within the home will die. If you ever go through and start reading on carbon monoxide poisoning within the home, it's extreme. There's all sorts of different levels. I don't even have to have death before it's a potential hazard to homeowners. If I've got below 30 parts per million, I'm going to have people that have brain damage, nausea, dizzy, headaches, fatigue. All of these things come from carbon monoxide, nitrogen dioxide, a whole slew of nasty poisons that come from burning combustible fuels. It's like parking your car in a garage and letting it run for 5 minutes every day, not long enough to kill you, but just long enough to make you start feeling the effects. It's going to permanently damage your bodies. It's not good for homeowners, so this is one of my real strong points when it comes to equipment within a home. We got to be super careful about this. You guys won't know much about this, I'm sure, but this is supposed to be for a ventilator fan. This is supposed to have a power ventilator. You go ahead and zoom out on these guys. These guys are supposed to have a power ventilator attached to it on a system. And what's going on here, this is an 80% furnace that is going to end up dumping carbon monoxide directly into the home. This is a valve, this is a flapper right here. There's no power fan on this unit. There's none. This is a direct vent into their attic is what's going to end up happening. This one's an extreme one. I've never seen it except for here. But you see something like this, this is definitely something to look forward to, or look towards to getting repaired. Let's check out a couple other pictures. This right here, this is something that cannot be missed on home inspections ever. This flue pipe right here that was going up through the ceiling has split. Sure, on the roof, a stick hit it, high winds, the neighbor threw their cat at it, I don't know. But either way, it broke that first joint. Something like this, I'm going to tell you what, if my guys see something like this, they're shutting the machine down. They're shutting the gas off to it. And we're not bringing it back on. They can yell and scream at me all they want, but this will kill somebody in their home. You see something like this is not a request, this is a must get repaired.
Another question. How would that kill somebody that's up in the attic?
You're going to end up with a potential to seep back down through attic pull downs. You're going to have gas in this area, in this space. Every time that HVAC system turns on, guess what's going to happen? You're going to pull air from that attic through the attic pull downs. When the fan turns on inside an HVAC system, it creates negative static pressure. Air takes the path of least resistance. If you don't have a good seal around your attic pull down, that air that's in that attic gets pulled down into there.
Carbon monoxide way heavier there.
Again, we've got negative static pressure. Air takes the path of least resistance. It's going to pull attic air down through that door no matter what its weight. So it's irrelevant. This has the potential to harm somebody in that home. There's no doubt about it. Trust me on this one. What else have we got? This one right here, yeah, this is horrible. Somebody had taken single wall flue pipe and jammed it in the bottom of double wall flue pipe for a hot water tank, I believe it was. All of this here, every time that machine starts up, is dumping exhaust gas right into that home. This has got to be making sure that we're taking care of it. We don't miss stuff like this. What else have we got? Here's that hot water tank. Here's the joint. That right there is the joint. As far as flue pipes go, I can have, I want to say it's up to 5 feet. I can have up to 5 feet of single wall flue pipe off a hot water tank in a conditioned space. This is what's key. If I have an unconditioned space, I cannot have any single wall flue pipe, ever. Okay? Conditioned space means it has to be within the home that has heating and air to it.
Can you say that again, please?
I can have on a hot water tank, I can have up to 5 feet of single wall flue pipe in a conditioned space. If that hot water tank sat in this room right here, I can have single wall. If that hot water tank sat in the garage or in the attic or in the crawl space, I can have no single wall. It must be B vent, double wall B vent all the way to that machine.
Is that to stop it from rusting?
Yeah, what will happen is this pipe right here will condensate because the gas going through it will cool below the dew point, which will allow the acidic gas to actually rot that pipe out. Okay. What's the next?
Is that a requirement?
It is.
You're saying, no, you're saying for water use, but that's any gas-fired piece of equipment.
This is where it gets a little bit touchy. If I've got a machine in an unconditioned space, if I'm touching it, as a mechanical contractor, I'm replacing a furnace that has single wall flue pipe, I have to bring it up to code, which means double wall B-vent. So if you've got a new furnace that was installed in the past couple of years, guess what? You see single wall on that, that's not up to code, and that contractor that put it in should be responsible. They were the ones responsible for bringing it up to code. I've seen older equipment that's 25, 30 years old that has single wall. As long as I don't have holes, rust, and rot, technically I can't force them to change it out. Okay. This guy right here, I have to have a minimum clearance around flue pipes for potential fire hazards. Is it 1 inch, 2 inch? Yeah, no, 1 inch. Thank you, guys. Sorry. So again, we're running into conditions to where somebody missed this one big time. We've got to maintain a certain amount of distance around 1 inch of any flammable material around the flue pipe. Okay.
The roofers do that.
Yeah, well, it depends. This is another one. Slope. We talked about slope on drain lines. The same laws apply to venting systems. If I've got a metal vent system, I have to maintain a 1/4 inch per foot slope minimum. Okay, this is a must. This right here is not to code because of this section of flue pipe right here to here is flat. It's completely level on this machine. That can't be. What will happen is this furnace will fire up. It'll fire up, and instead of the gas going up as a natural draft, it'll go backwards and dump out this hot water tank. If you ever have positive pressure at this hot water tank, you've got a problem. Collapsed flue pipe, a squirrel plugged up the flue pipe, pinched, whatever the case may be. You should never have positive pressure when that furnace fires up here at a hot water tank. It means there's something wrong with the flue pipe. It could be the roof cap came off and it's collapsed. We found a whole bunch of different things, but slope. Anytime you see flue pipe without slope or slope backwards, there's a problem. It has to be corrected.
Well, shouldn't that flue actually connect past those force fans? I think that's completely incorrect.
Yeah, the T on this was put in incorrectly. The T has to go downstream of where this machine is. It looks like I tied into the wrong side of the T as well. This T should be venting to the tank, and that other side should be dropping to the furnace. So they even have the T in wrong. Again, unlicensed mechanical contractors retrofitting these homes because homeowners go with the bottom dollar. Okay? Everybody knows that you get 3 bids, everyone takes the lowest bid, and it's usually John out of the back of his truck. What else we got?
Actually, on that image, is that correctly dead-headed gas line? And that's
Oh,
not a good
yeah,
image
go
for
back to that last one, I'm sorry. Good call. Yes, that'll work. I got my gas lines coming down, it deadheads into the trap, and I got clean gas exiting over to the machine, which I have black iron coming out. So good call on that, thank you. I didn't know I had any in here. All right, what else we got? So this, if you guys ever see a vent stack leaning over, I know it seems obvious and we all chuckle about it, but it's true. If you guys see vent stacks leaning sideways or whatnot, we need to have them straight up and down. Go ahead and go to the next one. I know I have another one in here. Oh, we'll go to this first. Holes. Yeah, woodpeckers. Holes. This is easy to miss. This is really easy to miss. We cannot have holes in the flue pipe at all, ever. It has to be a completely sealed flue pipe. Make sure if we're catching holes, cracks, rust, rot, we're looking for these things within the home because something needs to be taken care of. Go ahead. Yeah.
The long runs versus 75-25, maybe. The long run, 75-25 rule, but if you have a real long run, like flue, then you get a lot of holes like that.
We do a flue pipe calculation when we're working on equipment. We actually go by manufacturer specs versus BTUs of what the flue pipe can handle and the amount of gas of each appliance hooked up to it for calculations. So I don't know what is it a rule of thumb we're referring to?
It's in the code book. It's like 75 run, 25 rise.
Okay.
So if you're in an area that's got a super long run, it's got to get up and out.
Okay, go please tell me about it, please, because I want all this information out.
I don't know this section, but it's kind of, when you have a real long run, you'll get a lot of condensation sometimes, you'll get holes, rust, white solids called, sulfuric acid.
Sure. What that white dust and powder is the inside lining. It's the zinc coating inside the flue pipe that has gotten moist and is rotting out. The inside lining of the flue pipe is being eaten. I know I try not to get technical too much on this. Usually it means my flue pipe's too long. What'll end up happening is the gas inside the flue pipe will get below its dew point, which will cause moisture inside the flue pipe, which will rot out the zinc lining and cause that buildup of powder around the furnaces. It's usually either an oversized flue pipe or it's a too long flue pipe. Honestly, I can't double the size of my flue pipe on equipment, so if I've got a 4-inch appliance that requires 4-inch, if I go and dump it into an 8, we got a problem. And a lot of times it's because people pull a second machine off of it.
Yesterday I had one in the basement like you have a furnace and they had a water heater and they changed out to the high efficiency plastic PVC flue and they had still the 6-inch pipe for the furnace and they had this little 3-inch pipe going up and I said you might have to line that with something else, guys.
Correct. What we do in that application is we'll usually, if we can, we'll line it with a new flue pipe or we'll change out the hot water heater to a high efficiency hot water and dump it out the side of the building. Again, what he's saying is when people change out the machinery and the flue pipe's too big, we'll run into the same issue. We can only go so big with our flue pipe before the flue gases will not get out fast enough. Okay, again, that's something that we look for as mechanics because we have to go in and size the equipment that's actually going in the draft. What's that?
Is that caused because of the draft?
Yes, I don't have enough draft at that point. I've got too big a space and not enough volume going through it, which allows it to cool too much. I need that gas to exit the pipe hot.
To create the draft.
To create the draft and to keep it above the dew point, correct.
That's a very common problem, particularly in older homes where you have oversized gas pipes. Along the same line, I find a lot of issues where you have, especially crawl space, difficult access furnace, old ducts, you're pulling out the old unit, which is big and sized correctly for the plenums and takeoffs, and putting in a different one. There always seems to be a problem there. How do you address that?
As a mechanical contractor,
how do they marry that new appliance into the old ductwork?
I build transitions. One of two things. Either I remove the ductwork, the plenums altogether, and put in new plenums, correct size for the equipment, or I build transitions to them if I have an extended duct run. So I'm building the transitions between the machinery. And again, we're a very good company, so my standards of practices aren't the same as everyone else's.
You're not building a transition with 181 tape. You're actually going with
I'm using sheet metal, and I'm building a transition, and then I'm wrapping the externally with insulation to get the R value up, so I don't have a heat loss and gain through the. Yeah. All right, what else we got? This is a hot mess. We can't have tape on flue pipe. Okay, we just can't. That metal needs to be secure, it needs to be solid, it needs to be able to support flue gas. We can't have tape on flue pipes. If you see this, flag it. It's a problem. Get a contractor in to get it fixed. What else have we got? Okay, what else? Here we go. Here's a flue pipe that rotted out. This is actually the riser going up to the house, and here's what's left of the flue pipe going up to it. Look for rusted and rotted out flue pipe. This machine was still running when we found it, which means every ounce of that flue gas that was supposed to be exiting the home is dumping into that living space. Every single ounce of it. Okay, this is the conditions that you're definitely wanting to flag if you're seeing excessive rust and rot. And again, unconditioned space, this was in a crawl space. If you got moisture down there, it's going to cause it to happen. Make sure you do your inspections real good on flue pipes to protect the homeowners. What else have we got? This is a newer furnace. This was only a couple of years old. We've got single wall flue pipe from this furnace exiting out the roof. This is not up to code. The contractor that changed that machinery out had the responsibility of bringing it up to code. They didn't.
Gas line right in front of the machine.
Yeah, we got gas line blocking off access to the machine. It can't be serviced. This is the one with that drain pan that sat sideways that was too small. I mean, there's again, it's unbelievable what happens when you get people who don't know what they're doing involved. Yes.
You got to pull permit to replace an HVAC or all?
Supposed to.
If you're adjusting the ductwork?
No, you're supposed to pull permits when you replace the equipment. Yes. Next one. I've got 5 minutes, guys. I'm sorry. I'm trying to get this. Again, if you're seeing this thing's, there's something wrong with this. Something has happened. A tree has hit it, a branch has hit it, winds hit it, the pipe underneath became disconnected. This is a condition to where we need to get somebody to inspect this further. There's a problem here. Okay? We shouldn't be having bent vent stacks. They should be straight up and down, perpendicular to the roof. All right, what else we got? This one was a mess. Look for holes in flue pipes. There is a massive tear in this flue pipe right here. I've got a close-up of it in the next one. There. No, that's a different one. But I do have a close-up in here. Again, we've got tape. We've got tape on here. We've got, it looks like single wall up to here. This continued on another 8 feet and connected to B-vent. Somebody had run another 15 feet in B-vent after this. It's just a mess. This is the kind of stuff that we're looking for as inspectors, for new homeowners that listen, this has got to be taken care of before you purchase a home because this is an unsafe condition. Not only was it torn, but all of this other stuff, leaks, will happen. Go ahead and go to the next one. This was, I believe, this was in a crawl space. The equipment was too big. The furnace was too big, which caused this condition. It did not push all the moisture out of the flue pipe while it was running, which allowed it to rot and split in half. How long do you think this was running with occupants inside the home for it to get this bad?
Years.
Years. Who knows how many kids were in that house? Who knows what family members were permanently damaged, brain damaged because of this? This is what we get paid for as personnel, is to protect homeowners from this stuff. Go ahead and go to the next one. Here's that close-up of that split. It looks like just a little 4-inch gash. My technician, I had him fire this unit off and put a CO monitor next to that unit while we were running in that basement. You can see this is where people store their stuff. This is a used space. That thing got up over 50 parts per million within 5 minutes. Brain damaging, life-threatening conditions. Okay, what else we got?
Look for confined space.
What's not wrong with this? We've got tape wrapped around it. We've got single wall. We've got single wall going up to the vent stack where we've got combustible material leaning up against it where it looks like somebody chewed through the roof to make the hole. Again, obvious conditions that maybe we're not aware of. What else have we got? That's it?
That's it?
All right. What else is super
Look
important?
at confined space, guys, too. You can't have a gas fuel like in a small closet. You got high and low ventilation or fresh air somewhere.
I'll skip electrical, I'll skip that. Let's go, let me talk just for a minute, because I've got just a minute here. Let me talk about a couple of things that we do see in the field that I want to caution you on. We tend to want to use temperature guns for getting our readings on your deltas. And I'll caution you on this. When you're using an infrared temperature gun, you're actually taking a surface temperature, not an air temperature. And this is critical because we find a lot of inspections say that the machine only has a 15-degree delta or only has a 5-degree, whatever the case may be. It's not correct. That register right there is a metal plenum. It's a metal register coming out of the ceiling. If I turn that machine on and let it run for 5 minutes and I put my laser gun up there and hit that, I'm not measuring the air temperature coming out. I'm measuring how cold the metal is. It's a surface measurement. And so what ends up happening is if I've got a register that's been painted over 15 times, that ceiling's been painted and painted and painted, and we shoot that thing with it, that metal is insulated. It's not going to be the same temperature as airflow coming out. And your airflow is going to be colder, it's going to be insulated metal, it's not going to have the correct temperature. Also, if you shoot through the register and actually hit the ductwork in the back of it, again, we've got an insulated duct that's plastic, it's got a plastic liner. It's not going to give us correct temperatures. If you've got wood registers that are wrapped around it, they're not going to be even close to the correct supply air temperatures. My technicians are taught the same thing, is they have to use a measuring device and take it out to plenums with return supplies to get correct temperatures of the airflow going through it. And usually it's about 3 feet away from the machine if we can get it so we get proper mixture. If you get too close to the evaporator coil, you might have one side of the coil that produces really cold air, one side produces warm air. We need to get an average where it's mixed further down. So just giving you a heads up on that, because we have found on a lot of reports where temperatures were a bit off on that.
Thermal imaging.
Thermal imaging is a different story altogether. Thermal imaging, we can take exact readings of both air temperatures coming out of the registers.
I've had technicians argue that with me. I'll find 2 systems. One of them, you're picking up 65-degree temperature coming on the cold side, the other one 48. You're only questioning the one that was 65, not the one that was 48.
Sure.
You're using the same technology.
Sure. No, and I completely agree with that. It's if you go over to equipment down and go over to temp gun. These are what I'm talking about. These guys right here. These are the ones that I can get 6 different readings on the same one on the same register, depending on where I shoot. Because I'm not taking air temperature, I'm taking surface readings. And a lot of people are aware of that. That's nothing against anybody. That's just because we don't know what our tools do.
So a dial thermostat, analog thermostat, is a good idea then, right?
I use probes. I actually have probes that we put in the ductwork, and I either use a case style that I plug into a digital multimeter, or I push in one. Have multiple with you. I always have multiple temperature measuring devices in case I get a weird reading. I'll take it out and put another one in, just to be sure my thermostat's correct.
You mentioned delta T's. Over the years, I've heard all kind of different ranges which are acceptable.
Okay, good.
What is the acceptable?
There isn't one.
Because there's so many different factors that enter into it.
Correct. Correct. And I'm caution you, it's a good way to see if cold air is coming out, I guess. But to be honest with you, I've got so many different machines out there with so many different properties. I've got single stage, I've got 2-stage, I've got variable speed. I've got a compressor right now that I can go from 25 or 35% capacity to 100% capacity, which means my delta T is going to range from about 10 degrees to about 24 on the same machine depending on environmental conditions. It's going to ramp up and down depending on if I'm calling for dehumidification, or cooling. If I've got a compressor at 100% speed and the fan at 40% speed, I can adjust all this. And it changes throughout the day. So I got to caution you on it. It might be in first stage when you take your measurement, which is only going to give me a 15-degree delta, and then it might kick up the second stage after 7.5 minutes call for cooling, and it might give you a 21. It depends. There's a lot of variables in there that, unfortunately, I can't give you a solid answer on because there are so many variables.
My point, there's so many things people rely. They say, well, I had a delta T of this, so something's wrong. That's not necessarily true.
Correct.
Because there's all kind of factors that can go into that.
Correct. Now, if you're seeing something like 10, 9, 8, yes, definitely got an issue going on there. But if you start seeing 12 and above, what stage are you in? What's the load conditions? you know, what's going on, he's first. Go ahead.
All right, the couple things, the tamper-proof caps on the line sets, you
Yes.
should be seeing those guys. Sometimes they have a delayed start, so if you do pull the cover off and you go to start back and you go, oh God, it's not working, it may have a delayed start, like 5 minutes or something.
Correct.
And also, when is it too cold? I use 60 degrees. If it's under 60, I'm not running air. What do you think about that?
It depends. Again, you probably should be if you're running 60-degree temperatures. Yeah, you're going to cause potential compressor damage or whatnot, and you're not going to get accurate readings. They're going to lie to you. With me as a technician, I've got tricks where I can block off my coil's air supply, get my temperatures up, get my head pressures up. I mean, I got stuff I can do to run the systems when they're really low, which means that if you're in a situation where you need us, even if it's cold outside, we can also come in and check. I can check all the way down to about 35 degrees. I can usually do some tricks to get the system pretty well checked, even in really cold weather. But as far as just turning the system on, yeah, 60 is a good stopping point.
What about measuring the temperature of the condenser outside? You run your hand over the top of an operating air conditioner, you feel the heat transfer going on. Is it potential? Is it okay? A thought. This is a brain fart right now. All this is put a thermometer there and measure that temperature. And does that tell me anything?
Yes and no. If you have got a clean condenser coil, yes, I'm looking for a 10 to 12 degree on average temperature exchange between the entering air in and the discharge air out. That's with a clean coil. If I've got a dirty condenser coil, forget it. It won't tell you anything. It's going to completely lie to you because I might have a 30 degree and it's just because I don't have enough airflow. It's an air-cooled condenser. I have to have airflow through it in order to pull the heat of the refrigerant out. If I don't have the airflow, it's going to cause high head pressure, high temperatures. It's going to cause a whole mess of things. So if I've got good air, good clean coil, I know it's clean, yeah, 10 to 12 degrees is kind of a good range to work with. Yes?
Yes, so tell us about a brand new townhouse in D.R. Horton, brand new carrier systems. One's a gas system with heat pump. You turn on the AC, you drop it, and it won't drop. It stays right on 80 degrees. Tell us about what they've done. You can't run the AC below 80 degrees.
Thermostat's locked down, probably. It's locked, the thermostat's locked.
Is there any way to undo that? Or?
There is.
Yeah, you have to go to the installer configuration and turn the locks off on it. Every manufacturer's got different installer parameters to get into. Sometimes the homeowner's user manuals will tell you how to take the locks off, but I can go in and personally, and I can get into the installer's configuration. I can set locks up to set so you can't change the system. And usually it's secret keys to get into, hold up and fan or down, and you know, it all depends on what the thermostat is and who makes it.
Again, something we should not be doing.
No, it's not. You should talk to whoever currently owns that home to ask them to remove the lock so you can thoroughly check the equipment out. Yes, sir.
Just real quick. So our standards of practice require us to report temperature differential.
No.
It says right here, report any defects and deficiencies, including temperature differential. So I'm looking at right now here on our website.
So the best thing to do on that, and now don't get me wrong, I'm not telling you not to check your temperatures. Always check your temperatures. It's going to give you kind of some set points. If you got one that's pretty 17, 18 degrees, we got a pretty good idea that thing's cooling all right. You know, just putting some air out. I'm not telling you that. I'm just saying you got to be careful on saying, because we've seen reports too. It's at 16 degrees and it must be 20. Well, not necessarily. And that's the only, because then we have to fight with the homeowner saying, well, that system's not working. Well, no, it is working. And they're like, no, the inspector said it wasn't because it's not maintaining 20 degrees. It's like, okay, hold on a second.
Yeah, so the only reason I'm raising that is because I'm familiar with some of the things you're saying.
Yeah.
A lot of disagree with how you should measure it, where you should measure it.
Sure.
Measuring temperature versus energy even, like there's a bunch of different
debate
on that whole topic.
Sure.
But just our standards of practice do say that, so I'm just raising that to the board. Is that something we still want in our standards of practice in our discussion for another time? But right now we are required to report that.
And I think it should be. I think the indoor temperature.
Reporting what it is, just
I think your values should be entered in your reports. On this day, 80-degree day, I had an indoor temperature return 72 degrees. I had an output temperature of 52 degrees. Whatever the case may be. Oh yeah, report that because that's great information for us. Because as I'm coming back in as a mechanical contractor, the more detail that you guys put in there of what you're seeing and what you're looking at, I can get in and get it fixed better. And what you guys don't know is a lot of your reports, guess what they do? They start calling up random mechanical contractors to how much is this going to cost me to fix? Well, send me the report. And if they send me the report, which they usually do, I can go through your guys', if I got good pictures, I love good pictures, you guys take good pictures, you're giving a good description, I can go through and I can pretty much quote over the phone with that homeowner what it's going to be so they know when I'm coming in the door what it's going to cost them. So the more detail, the more reason of why you're failing something, the easier it is for both the homeowner to get it fixed and for me to be able to quote. Okay? I'm going to turn this over to Brad. Yeah.
In terms of comparison, you said that using a thermal imaging camera is better than using that joint?
Yes.
Okay.
By far, thermal imaging camera is going to give you temperatures all around everything. It's going to give you exact details. You can typically take and point exactly what the temperature is. It's going to give you a more accurate, better range of everything in that area. Not just this spot on the wall right now is at 46 degrees, but this spot over here is 80 degrees. It's actually going to show you what all the temperatures are in that range. Okay, guys, this is Brad Lucky. He's the plumbing manager for RS Andrews. Please welcome him.
Yes.
Does anybody need a break? We can move on.
Press on.
Okay. All right, so we're gonna go over just a couple of plumbing things. Not the obvious. You guys get the obvious all the time. We're gonna go over a little bit of water heater, tankless. We're gonna go over some cast iron drain lines. Some things to point out with that. So we'll start with thermal expansion. I know everybody knows to look for that thermal expansion tank. Can you guys hear me okay?
Yes.
All right, how about now? Good.
That's not required, though. You can have a valve, right?
Yes. It's questionable. You can have a thermal expansion device. However, in the next year or so, our water restrictions are going to eliminate that, and it will be to this tank. So currently, yes, you can have a thermal expansion device. Any contractor putting in a water heater now is going to take that device out and put a tank in. So to look for your thermal expansion tank, obviously the working pressure is 150, which is way above where the house should be. Operating temperature is 200. Factory pre-charge is questionable. That really doesn't even matter when you guys get there. The simplest way to test that is either open the very top, which would be right here, and insert that. If you get air out, the tank's usually good. If you get water out, the tank's bad. The other thing I always do is I take my little Leatherman here. I tap the tank. If it's a nice ping sound, it's full of air. If it's a thud, then it's full of water. And that's crucial. You guys, every one of you should do that, simply because when the homeowner goes out of town and we leave that water heater on. If it fires 3 cycles, 15 psi a cycle is the pressure we're adding to that home. So that's an extra 45 psi. So they could potentially be at 95 if they already have high pressure. We could start blowing out lines, etc. That's something real easy to catch and look at. The other thing is, this is a tank. That picture on sizing is a 2-gallon tank. So anything 50 or below, we can have that. If they have 2 water heaters or a 75 or larger, we have to have the larger 4.4 gallon tank. So everybody, I'm sure, has seen the 2 different size tanks. 2 water heaters, larger tank, 75 gallon or larger. You would want the 4.4 as well.
Would you install a water heater without having one built on there?
I wouldn't know. So if I put, it is required. You have to have a thermal expansion device. I wouldn't personally ever put one in without a tank. But a thermal expansion device is required, but the tanks are the most common. So we're not going to get into odds and ends here. We're just doing the most common practices that you guys are going to run across.
Are they still allowing the thermal expansion valve?
You can buy them at Home Depot, but they're It's the gray area. Once again, it's not the plumbing code saying that you can't have that, because plumbing code says you need a thermal expansion device. This is now going to cross over into the Georgia Water Act. So that's something else to look at, is a way to escape around all of that is we just put the tanks in. Then we're covered 100%. We have no issues down the road.
But if we get questioned by our client that we're requiring that or saying that should be,
Device.
so that's how you work.
Yeah, they got one that they put in the tanks of the toilets that you can say there are okay now too.
Correct. And
the valve, you can see what they have.
I mean, the ones in the toilet are kind of a thing of the past because nobody wanted to hear that toilet running at 3 in the morning. But you can get what's called a Watts 120 valve, and that does have to be plumbed, not into the temperature and pressure line, but to the outside of the home. And if you have that and it is set properly, then it's okay to have that. We, as standard practices, cut that out, put the tank in. That way nobody's wasting water. We don't have another point of failure down the road, etc. So the big thing is, though, I do want you guys to know the sizing on them. You know, 2-gallon tank is 50 and below. 4.4 gallon tank is going to be anything over 50 gallons, whether that's 2 40-gallon heaters or 2 50-gallon heaters. So simply just a brief overview on how this works. That tank needs to be pre-charged to working static pressure of the house. So every plumber will come in and say, okay, you're at 62 PSI. I'm going to pump my tank up to 62 PSI. Basically, for lack of a better explanation, I tell all the homeowners it's a metal tank with a rubber bladder full of air in there. That tank is going to actually absorb the extra pressure that expanded water is putting off when it heats up. So that's simply all it does. It's very, very simple. So with water heaters and looking at the ages, I'm sure everybody's pretty familiar with this, but usually we're looking for the first 2 numbers. That's going to give us the week or the month, depending on that it is manufactured. And then the second set of 2 numbers, and there may be over here, you know, several letters that may have a number or 2 in it, and we're not going to pay any attention to that. We're looking for the first set of 2 and then the second set of 2. The second set of 2 is going to give us the year. That's almost on every water heater.
What about Bradford White?
Bradford White has this really nice little app that you can download onto your phone. If you go to the App Store and just type in Bradford White water heaters, it'll give you all their date codes. So Bradford White does a date code for a year, and it's A through Z, and then they have that same date code for their month, A through Z. Not A through Z, obviously, there's only 12. But, yes.
I was gonna say, guys, there's a website that, where it looks like that may have come from. I have it on my computer. I'll have Will send it to all you guys. It's really neat.
I did pull this off of that website. This website has 5 different kinds of ream configurations. It has State, A.O. Smith, you know, every water heater on the market. Well, this website will have, but as a rule of thumb, you're just looking at the first 2 and the second 2. If it's a Bradford White, date coded on your phone. If is that a requirement to give an age of the water heater?
Yep.
That is. So I recommend pulling the Bradford White app up on your phone then. That's a pretty good app they have. Okay, quick overview on temperature and pressure relief valves. First off, PVC is unacceptable. If you ever see polyvinyl chloride, the white pipe, it's a no, that needs to be changed. We can use any metallic pipe. So here we got 2 different kinds. We got galvanized as well as copper. You can use CPVC, chlorinated polyvinyl chloride, or you can use polyethylene pipe, PEX pipe. So here we have no drain valve. It is required to have a drain valve now for servicing purposes. They're required to open this up once a year, replace it every 4 years. So if you don't see a drain valve on that TMP line, when it's going uphill, so if it's going above this, then there's no drain relief. And that drain can be any number of things. Here I have a picture of the brass elbow with the cap everybody I'm sure has seen. I always put a drain valve on mine, so I'll put a T here with a drain valve on mine. Any way to let water vacate that. The reason that that is so important is there's a small spring right inside of here. And if water sits on that spring, because in between that spring and that water inside of that tank, there is a piece of rubber, and that seals it. The spring isn't rated to have water on it. So that spring's gonna seize up, and essentially this thing can become a missile. Everybody's seen Mythbusters where the water heater blows up through the house or goes 40 feet high. That's essentially what blocking that off or having that rust out does, yes.
On the lock installation instructions, it says it needs to discharge downward. So if it goes upward, doesn't that void the instructions?
It does not void the instructions. It can actually discharge out the side. It just can't immediately come off of here, so you can't spin that around and have those threads pointing upwards. It can go any way you want it, because when this is open, this is a pressurized line. It's an emergency evacuation line. So as long as you have a drain valve after it's been open to allow the water to drain down, or after you do your servicing, drain the water down, then it would be okay. But you cannot come off of this with threads up in the air, because then you have no way to get the water off of that spring right here.
That's a 2014 Georgia amendment.
Yeah, I'm giving some amendment codes, which there's a good website. If you go to Georgia Plumbers Trade Association, a guy named Ron Anderson runs that. He has all the Georgia Amendment plumbing codes on that website. You can print them off or put them on your computer in a little file.
Where's that website?
It's Georgia Plumbers Trade Association, or gpta.com.
This particular one, I think, is the 2014, is when Georgia amended the code, which did require the gravity flow originally, but the amendment allows you to be able to turn it up provided you have a drain valve in which to drain the standing water off, which is stupid, but anyway.
So here, this water heater and expansion tank is set up correctly in the fact that you have the expansion tank prior to this water shut off, so that no matter what happens, if you shut water off to this, it continues to heat. This thermal expansion tank will still work throughout the house. You know, oftentimes you're gonna see shut-offs before you get to the expansion tank, so we can just shut it off, swap out the tank. I wouldn't get too picky on that. That's okay, but technically you're supposed to have the shut-off after the expansion tank, wherever that may be.
What location of that tank?
It doesn't matter, cold side, after the main shut-off valve. So anywhere in the house on the cold side after the main line shut off.
Can the tank be turned on its side instead of straight up?
You can turn it on its side. There's no technical requirements. If you read per the manufacturer of each tank, some says they want to be 18 inches above that water heater. Others say must be supported. That's.
Well, can't the tank be, instead of this way, can it be?
It can. I almost always will pipe mine with a T and either lay it on the back side of that water heater or support it against some rafters if I have that option. I don't ever really want to just leave a tank unless it's like this where it's supported all right there. I don't ever want to leave a tank off of at 90 degrees just hanging there. When it fills up with water, you've got roughly 16.5 pounds plus the weight of the tank. That's a lot of stress on those joints.
Question?
Yes.
So sometimes we're taught to check that TMP, sometimes we're told not to check it. What's your...
I wasn't even going to go there. So when I come out to a heater, the first thing I do is look at the age. That's going to let me know first if I need to have the discussion of this thing's beyond us, you know, rejuvenating it, etc. Or, you know, it's 3 years old, this thing needs to be tested, I'll pop it. You know, more times than not, that's going to continue to leak. A little trick of the trade is when you pop it and it does continue to leak right out here, right outside of that spring, if you take something, once again, my Leatherman's on me all the time, so I've learned to use it. But if you take, you'll see a little teeny needle at the end. If you just tap that a couple times, More times than not, that'll seal back up until the next time somebody walks past it. So that is up to you guys if you want to take that risk or not, because the homeowner is going to say, well, it wasn't leaking before you got here, and now it is. That's a given.
That said, if you go like that, you also take the pressure off the water heater by simply turning off the water heater, open up a faucet, turn it back off, that will leave the pressure on.
Yes, you can do it that way too. You run into a whole nother set of problems when you start turning shut-off valves. If it's not a ball valve like this, then make sure you have a little channel lock to tighten that packing back up. Is it common for you guys to shut down toilets, sinks, all of that, or just look at condition of valve and move on? Okay. So I wouldn't, when we do our whole house inspections, it is a visual inspection on what we can see, plus a few other things. We don't get into turning valves because, as everybody knows, they tend to leak if they haven't been exercised in a while. Yes?
Sideways thermal expansion tank, is it okay to just strap it?
Yeah, absolutely. Just strap it. So pressured lines don't care which way anything is because it's pressured. So you're gonna get the same result one way or another.
How about replacing that tank if the water pressure is over 80 for an extended period of time?
You almost definitely should. That tank more than likely is not even going to be operating if it's been over 80 for an extended period of time. The majority of contractors who install these install them because they know they have to. They don't know they're supposed to pump them up to the static pressure. If it's pumped up to the static pressure at 60 psi, and for 6 months you're at 90 psi until somebody comes out to check your pressure, that tank will probably be okay. But our practice is whenever we find high pressure and we replace a pressure reducing valve, we also at the same time would check that tank. And then after we install that pressure reducing valve, we will then adjust the tank to the new static pressure.
Do they come pre-charged with a certain pressure?
They come pre-charged between 20 and 40.
So you're saying that if the house pressure is double that, it's liable to fail then?
Within probably 6 months, that new tank will be worthless. So we're going to move on to water heater pans. Is everybody good with thermal expansion tanks, the purpose of them?
Yep.
TMP lines, all of that good stuff? Yes?
So you tap it to make sure you hear that like it's full of air versus water to make sure.
Correct. You'll hear a thud, a distinct thud.
If it's full of water, you don't want that.
Correct.
On the bottom first.
Yeah, I mean, you can tap it, you can start at the top and run down, or start at the bottom and run up, but after you do a few of them, you'll get the sound down. That's the easiest way. You know, you guys see tons of these, so if you start on Monday, by Monday afternoon, you'll be an expert in that sound. So the only code on pans in this state are when installed above a ceiling or in an attic. So that's it. Not above a crawl space, not next to finished living space, etc. So water heater pans got to be 24-inch gauge. I say metal, but we do have a Georgia amendment which allows us to put plastic pans under electric water heaters. So we can do plastic pans on electric only. But other than that, they need to be metal, especially for gas. Water heater pan draining. It's a whole different animal. They say that a pan must be installed, but if you're on a slab and you've got 4 sides of living space around you, common sense would say, I recommend you have somebody come and put a pan in here, but we can't drain that pan. We do have valves that are flood sensors, basically. They sense water, they electronically shut off water to that unit. So in that case, 40 gallons is a whole lot better than unlimited gallons until you get home to find it. More times than not, when you do shut the pressure off to that tank, that leak also stops or goes to a very slow drip. So those aren't bad options to recommend to people in cases that we can't get a drain outside. This is an emergency drain. There are no real codes on it. We can use PVC on this. You know, CPVC, etc. You may hear a lot of different things on how that works. This is considered an emergency drain, so PVC is an acceptable way to get that water out. The thought behind that is PVC is not a heat-rated pipe, so by the time it gets to the pan, we're assuming the water heater's already been drowned and the pilot's off. The water's cooler at that point, but once again, the important thing is it's an emergency drain. So an emergency drain is just that. It's not code regulated. So when dealing with this above a ceiling or in an attic, the exception to all these are tankless water heaters. They're not required to have any kind of pan anywhere in the house. So gas shutoffs. I threw this on here. This is what I call a spring-loaded gas shutoff. It's no longer an acceptable gas shutoff. Old appliances, new appliances, it doesn't matter. I mean, if the water heater's 20 years old, probably make a note of it and say water heater's 20 years old, it should be replaced. Replace the gas shutoff. But yes.
Speaking of the age of the water heater, what is the expected life cycle of a typical water heater?
In this area, metro Atlanta area only, 10 to 12 years. We have pretty good water quality here. Most high rises in Atlanta mandate their tenants or owners replace every 10 years because they do not want a 40-story flood. But 10 to 12 years is a good range. That's not to say you can't get away with 15 years commonly here. At 10 to 12 years is when you definitely need to be thinking about replacing that. Standard warranty on water heaters out of the factory is 6 years. Then you can do some things, put an extra anode rod in to extend that warranty if you'd like. But in this area, a 6-year warranted water heater from the manufacturer is usually going to get you 10 to 12 years. Yes?
Strange question. Shark bites in water lines on an electrically grounded copper system. Isn't there an isolator in the shark bite that negates the grounding capacity?
There is. Anytime you have non-metallic and the inside of that shark bite is plastic, anytime you have non-metallic, you should have a jumper wire over that. You also should have a jumper wire between the hot and cold line above the water heater as well.
So what's wrong with the valve on the left?
It's a spring-loaded valve right here. So on older spring-loaded valves, as soon as you turn that off, it's going to start leaking. Then you'll have to go shut the whole house down. Correct. It's no longer ANSI certified. Therefore, it can't be in your home. That's essentially what it boils down to. But it will. I was going to put some different valves on here, but they're not against code. But they will also, everybody's seen those big, thick brass valves that you need channel locks or a wrench to turn off and on. They have that big nut on the back. Those are going to leak every time you turn them if they haven't been used in a while too, but you can stop that leak by tightening that nut on the back. So it's not as big of an issue. My recommendation would be if you see new equipment with this on there, then say have a professional come look at it because more than likely that guy didn't know or didn't care enough to change it out. We should have all ball valve type shutoffs now on gas. And I'm only doing this as just simple things you guys can be walking by equipment to look at. None of this is set in stone saying it's got to be replaced. This is more to help build your brand and your value up, saying, hey, I noticed the guy left that in there. Those are no longer ANSI certified. I recommend you have somebody come check that out. At that time, we'll check the work that he did out as well. One day I'll figure out how to operate this thing. So tankless water heaters, and we'll go into a little bit of detail about tankless water heaters. Two really simple and easy things to look for without knowing nothing about tankless water heaters is this install kit here. And you could make a homemade one of these, but you need a shutoff valve for hot and cold. You also, because you have to have with any tankless a way to isolate hot and cold. So one cold shutoff valve is not going to work. You also need a way to hook up hoses and or recirculate to flush that tankless. So right here we have a hot and cold shutoff valve, and that shuts my water supply off. Right here I have a hot and cold shutoff valve, which allows me to hook up hoses. So the reason that's so important is every single manufacturer of a tankless water heater is going to require you to flush that at some point. So you will have to hook up hoses to that, isolate the hot and cold water from the rest of the house, and be able to circulate water through your tankless. And there's all kinds of different solutions out there. We use distilled vinegar because it's food grade. We're not going to put chemicals in your water you bathe and drink. Go ahead.
How often should you descale the tankless water heaters?
That's up to the manufacturer. Renai recommends once a year. Navian says my machine's going to tell you when it needs it. Norris says 1 to 3 years. It's up to the manufacturer.
No longer than 3 years without maintenance.
I wouldn't. Certainly wouldn't go longer than 3 years. Once you start getting into the 5 and 6 year mark, if you haven't done anything to service that water heater, once you go to put that vinegar in there and descale those lines, you're also going to start causing all the rubber gaskets in there to leak, etc. So, you know, sometimes we do have to tell people you're going to have to ride this out. This thing's 7 years old. If we do this now, we're going to rebuild this whole thing in 6 months. So the tankless install, anywhere from 3,000 to 5,500. Yes.
How about average life expectancy?
If maintained properly, you're going to easily get 15, 20 years out of that. Renai comes with a 12-year heat exchanger warranty, so you know you're going to at least get 12 years out of the deal. But in the area we're in with our clean water, if you're going to invest in one of these, then maintain it, and it's going to last you 15, 20 years, no problem.
How often did you say flush it?
Renai recommends once a year, but I wouldn't go any longer than 3 years. And Navian will tell you that their remote control is going to tell you when it's time to descale. I've had a Navian in my house for about 8 years. I've done nothing to it, simply because I want to see how long it's going to go before something gives. So I'm just using it as a guinea pig. And the other really quick thing is just by glancing at this, make sure it's got an install kit with the temperature and pressure relief line, of course. That is no different than any other hot water heating device. It's got to have that. And a union somewhere close or on that tankless water heater. If they hard pipe a gas line into there, then there's no way for us to take that off the wall to either do service or to swap it out without cutting that gas line or taking down the whole gas system to get to it. So this is required by every manufacturer as well as code. You have to have some kind of way to break the gas on that. And that can be done, it doesn't have to be hard pipe, that can be done by a 3/4 inch or 1/2 inch flexible gas supply line as well. Just need to have a shut off and then a way to break that system from the gas. Well, the sediment trap on this picture, which I took off, this comes over and comes down. I have a gas shut off, and then my sediment trap, my gas comes from here, my sediment trap's here, and then it runs over. So I do not have to put a sediment trap exactly on that unit, as close as possible. Was it possible to put on the unit? Yes. My process is we do a union, I do a small nipple, I do a gas shut off, and then I put my drip leg under that. My gas comes in the side of it right here. That's how all of our tankless water heater installs look, but that's not code. It's as close as possible. So there's tankless gas connection we just went over. We're going to jump over to cast iron drain lines real quick. It's probably you recommend cast iron drain lines, have somebody come look at them anyway. But in glancing, this line doesn't look overly rusty, it doesn't look too bad, but we do have what we call weeping, which are these little rust bubbles or rust pockets. Please do not touch those, touch the bottom of the pipe. Your finger will literally go through that pipe, and then it's a mess. But just do look out for weeping or rust bubbles, anything like that. They're not going to be very big at all, but that is something quick and easy to look for. We know that that pipe's rotten at that point. Yes. 50 years. I mean, every pipe, everybody's going to tell you 50 years. If it's a kitchen drain line, less than 50 years. If it's a vent line, 150 years. So, yeah, and this looks like it's in a crawl space to me, but then you got sheetrock right there, so I have no idea where this is. But you know, just in glancing, these are all things you can just glance at, walking to something or walking from something, and see, okay, I see that's pipes weeping. Let's make a note of that, take a picture of it real quick. Also, the other big tell of cast iron is when you have spots of PVC that have been replaced, but not the whole cast iron job. A lot of people don't want to deal with that. A lot of people don't want to take the tree out, which the tree is everything runs into, and then your cast iron pipe runs on out somewhere. But just look for when they piece it together. More times than not, the first to go is going to be a kitchen drain line. So that's not that uncommon. That doesn't mean the rest of the cast iron's bad, but we would want to make a note if you see a laundry drain line that runs 20, 30 feet across the crawl space and you see 2 or 3 spots of PVC in there, go on ahead and note that and say, this line's bad, almost definitely, and have somebody come out and look at it. We very often have folks that will move into a home and go to fire up that washer, boom, start flooding everywhere, etc. We get under there and it's just patched together. So just make a note of that, however, whatever your normal practice is. More times than not, that cast iron is going to be bad. If it's patched, not all cast iron is bad, and not all cast iron needs to be replaced by any means. But I'm just trying to point things out that you guys can easily see and make a note of. So even if the cast iron has, you know, rusting like that, well, that toilet 20 years ago could have had a bad wax ring. So that doesn't necessarily mean that it's active and it's bad. You know, that looks pretty solid to me. But
are there any certain types of particular connections that you need, like you have that PVC going into the black cast iron? Is there special fittings or?
So this fitting is done correctly. There's actually supposed to be what's called a no-hub reducer with a no-hub band, which is a stainless steel band with a rubber inside. This fitting over here is called a Fernco fitting. You're not really supposed to do that transition. You can do that transition if you're going from cast iron, which is a smaller inside diameter than PVC is, to PVC, but you don't want to do it from PVC to cast iron, because then you're taking a big pipe into a smaller pipe, and that's where all of your waste is going to build up right there and cause a problem. So you would want to put a no-hub reducer in, and all that simply is a fitting that you would see a metal band around. It reduces the inside of this pipe to the cast iron size in a nice gentle way that won't create any turbulence for buildup. Toilets. Everybody's got toilets down pat here. One thing I just do want to make aware is that code says that there's got to be a seal from that bowl to the floor, whether it's a grout or it's silicone. And a lot of people don't want anything on hardwoods, and that's fine, I get that. We have clear silicone for that. But do make sure that there is a seal around that bowl. If they have a small gap behind the tank on the backside, if they're on a slab or something, that's okay. I always leave a gap there too, especially on slabs. That way if it does leak, it'll leak out that backside and we know it's leaking. So make sure it does have a seal there. I know everybody checks for wobble and all of that good stuff, but the seal is important. Saddle valves, I don't know what your procedures are on those. My recommendation would be don't touch them. But ice maker lines often come off of these. They often probably look like that when you guys see them. It may not actually be dripping at that time, but as soon as the people living there move out, they turn that off. It's never going to turn back on and work properly. So just make sure that they're aware and things to notice, etc., that you're going to be calling a plumber out to install some kind of shutoff valve for that ice maker at some point down the road. All right, corrugated stainless steel tubing, CSS for short. There's a few types. There's a yellow one and a black one. Yellow one, several different companies make. I think you can get this stuff at Home Depot now. So all yellow one has got to be grounded. No ifs, ands, or buts. If it's yellow, it's grounded. Counter strike, which is made by Track Pipe, can be not grounded. It does have to come to this brass fitting. The black needs to come to this brass fitting, or if they cut it short, they need to wrap it with electrical tape to continue that. This is a special coating that basically allows you not to have to ground it. But this coating does absolutely nothing if we cut it here, and then we're not attached back to iron pipe somewhere in that house. So it either needs to run all the way down to a brass fitting, or we need to put electrical tape around this. And this slide will show proper grounding and what it does. That's a house that got hit by lightning, and this is not that uncommon actually. It literally blows that out. Next thing you know, you have gas pipe blowing gas everywhere. Yes?
In several states, they're required to add the verbiage that you have to have a licensed electrician to verify the ground at the primary ground or Euclid ground or wherever. Is that also in Georgia?
No, we're on the good old boy network here.
That's what I thought.
So it's, you know, we're allowed to hook up water heaters, disposals, dishwashers, all of that.
It should still be grounded, correct?
100%.
Per manufacturer's record.
On this yellow, yes, not on this black pipe. This black pipe, the whole reason they came out with it so you don't have to ground, because no plumber carries around a bunch of grounding stuff in their truck to do a whole line. But this is the proper way to ground if we needed to ground yellow line somewhere. We have black iron. We have the brass fitting from our yellow gas line for corrugated stainless steel. On that fitting, we have the grounding clamp. So that's not to say you can't ground it from that side and run it across the yellow. It needs to be grounded on a brass fitting, and it needs to be grounded to that black iron that's going to the meter outside somewhere. Any questions on the grounding?
Every section?
Yes. So if it's broken up, then it needs to be grounded. So most of the time, when we used to run this, we would just start it wherever the appliance was, and we'd ground all the way back. That way we were covered and it wasn't an issue. All right, that's can we get, oh, he's not there. Yes?
Like stinky water heater. Sometimes you don't see it, but how it's been a long time. What causes the stinky water? Or do you have to be replacing water heater?
You don't have to replace the water heater. A lot of times off of wells you get that, and that's actually a something in the well water. It's an anode rod thing. If you have a zinc anode rod that's causing that sulfur or rotten egg smell, you can get a different anode rod with different metallic makeup, and that problem will go away usually within a day or two after you cycle all the old water out. So that's all. That's a simple anode rod fix. That can be handled pretty easily.
What about Marathon Electric? Are they like super good or 50-year guarantee they say? Or?
Lifetime guarantee. Lifetime guarantee until you guys come in because they're selling the house. The new homeowner gets a 15-year warranty after that. They are good. as long as the pressure in the house is maintained and under control. The weak point on those are where the water connections are at the top of the tank. They have a brass piece essentially encased in rubber, and that's the weak point on those heaters. Yes?
What's the difference on a water heater between first hour rating and the recovery rate? Is sizing water heaters for new construction, we have to know the FHR or Georgia Code. But what's the difference between the two?
So the first hour rating is your tank's 100% hot at 120 degrees. It's going to, by some calculation that the government says, it's going to produce, we'll say, 94 gallons of hot water, which is really not going to be the case, but in ideal conditions, that's what they say it is. And then what was the other one you were asking?
Recovery rate.
The recovery rate is a more realistic usage. So if I drain this water heater all the way down, a 50 gallon is going to give you roughly 38 gallons of actual hot water, because you're dumping cold water back in the whole time you're using it. That's going to factor into your recovery rate, and that's kind of how they get that.
I thought the two were identical, and the voter busted my chops on that.
To each his own on that, you know, so I'm trying not to get too specific because each municipality is going to be different. And then within that municipality, each inspector, building inspector, is going to be different on that. So if you're doing a neighborhood and you know you've got a building inspector there, you call him and ask him what he wants. That's the easiest way to skirt around that. Any other questions?
Or either parallel or in series?
Either or.
Doesn't matter?
No, it doesn't matter. If they are parallel, it is extremely important to make sure that the T for the cold water and hot water are in the middle of the two water heaters. So that way you get equal draw off of A and B. If that T is on one side or the other, then you're going to get draw off of one heater more than you are the other. But when they're in series, the water heater A dumps into water heater B. That's going to maximize your hot water potential, because you get 50 gallons out of A 100%, because when you're using B, you're still dumping hot water into it, and then you're going to get your 38 gallons out of the other heater. So you get the most bang for your buck when you do them in series.
You just answered the question.
Okay, yes.
A gas expert several years ago made a presentation, said that if you have typical tank gas water heater, that baffle in the middle of the tank, those fins absolutely have to be in little clips to the side. If you've got that thing askew or the clips are sitting on top of the tank, that water heater burner will not vent right. Have you heard that?
I haven't heard that, but the manufacturer puts those places for that baffle to go in. So I'm OCD, I always make sure it's in that spot. It, to me, wouldn't make that big of a difference, because if the flue vent's doing its job, then no matter where you spit that air out within that vent cap, it's going to go up the flue.
Supposedly, that thing has some sort of design to it. If it's askew, it was not let the heat off the burner properly. And they said that's one time where you see that roll out at the bottom because it's not venting properly.
Well, that rollout at the bottom is non-existent on new heaters. They're all flame lock technology now. But I guess I could see where that would come into play. Hot air is always going to rise, though. So I don't know.
What is the true life of water heater today? Out of tank?
10 to 12 years. Yeah. Yes.
When did ceiling toilets become code in Georgia?
I know it was code in 2006.
And 2000.
And 2000, so.
98, still bump.
Yes.
We're seeing more people, either because of popularity or because of the function, wanting to go to tankless water heaters. I mean, they don't know why they want to, they just know that I'm going to change this out to tankless water heaters. What's some of the couple of the most common installation problems you see with aftermarket or people coming in for the
So with tankless water heaters, the first thing we look at is the venting and the gas. I'm going from a 40, maybe 50,000 BTU water heater to 199,000 BTU appliance. So I have to make sure the gas is there. The three-quarter gas line is, okay, but Renai says I can run 25 feet of half-inch gas line to their unit, but only on particular units. So what I have to do after that 25 feet is I have to make sure that whatever's tied into that is going to be able to carry that load over. The biggest thing with gas is we got to go through the whole house, do a BTU load count first to make sure the meter can handle it. Then once we do that, I have to find out where I can take 200,000 BTUs off of, not affect any other appliance in the house, and run it over to where we're putting that tankless water heater, which can get very expensive when I have to run almost always first draw off the main gas line across the house and put it on the tankless. The second is the venting. With condensing units, now we can run PVC. That's helped a lot. But if we don't have anything that is a condensing unit, we have to use that brand's proprietary vent, whether it's a concentric vent or a special stainless steel vent. And that can get very, very expensive if we have to run even 20 feet across to get it outside. So it's gas and venting are the two biggest issues by far. We can run water anywhere relatively easy, so water is never really a big problem. I can build a stand to put a tankless in the middle of anywhere, so that's really hanging, it's not a problem.
If you catch them going down the old water heater locations here, they just come through, they just mount the new tankless water heater on the wall behind where the water heater was to tie into it. Most likely that's wrong.
I'm telling you now, 100% wrong. That is not, you can't put a tankless water heater into a B vent with the exception of an Aquastar, now known as a Bosch, which they don't make anymore after the new water heater standards. Yes?
Relative merits of house pipe, copper, PEX, and CPVC. What are we gonna see? I know copper gets thin wall and you get leaks. Any problems with PEX, PVC?
CPVC gets brittle after about 10 years, but that's a me problem. If you just look at it and never touch it, then nothing's going to happen to CPVC. It's when I go to cut into it and I try to cut into it and use too much force and then it cracks a foot down the line. But, they're all good water pipes. So every water pipe's going to have their problem. I would still probably do my house if I were to build a house in type L copper. There is a small chemical difference between M and L. M's the thin wall, L's the little bit thicker. When they do type M copper, they do something in the manufacturing process. If you notice when you look at all these homes with all the pinholes in that copper, it's all on M. If you see any kind of type L copper or even flexible copper, you won't see those pinholes because even all flexible copper is type L, although it's not labeled, that's what it is, it's a thicker copper. So I don't have a good answer to that. They're all good water lines.
Any problems with PEX? Because now that PEX owns the new construction.
I
haven't seen any.
I haven't seen any problems with PEX. I don't know about the plastic PEX fittings. I would the brass fittings are the way to go when doing PEX. I haven't seen. I thought I heard of maybe one lawsuit. I don't remember if it was Zern or possibly Watts with those plastic fittings they had, but it's kind of been swept under the rug at this point. So
metal fittings preferred on.
Definitely.
The old China fitting.
Yes.
I'm seeing a lot of these new green professional electric water heaters. It's like 50 gallon installed in the place of the 66 gallon that may be required by the Georgia amendments. Plumbers are telling me that its recovery rate is faster than the typical electric water heater. Is that true?
If that's what the manufacturer specs say, then yes, that is true. You'd have to pull out the Rheem Pocket Guide. I know that Rheem does make a 30-gallon gas water heater. It's the equivalent of, more than a 50-gallon. It takes up the footprint of it so much smaller, we can actually get it in those tight closets. So that's not without of the realm of the possibilities. Yes?
Speaking of Rheem, I have been, in the past year, probably seen 15 Rheem brand water heaters with no manufacturer's data label on them at all. And I finding generally flipper houses. I'm wondering, could these be off brands? Could these be things that are supposed to be dumped for salvage and somebody got a hold of them? Well, there's no manufacturer's data label at all. Just a Rheem, no manufacturer's data label.
Is there a serial number? Then that's not a Rheem heater, or that is a Rheem heater that Rheem has deemed not good. Without speculating too much, this is complete speculation. When you go to return a water heater that's still under warranty, you take that plate off, and that's what you send to the manufacturer. They don't want to pay the freight to get that tank back to them, but they do want that nameplate. So that might be some of it, but I have never run across that. So yeah, and I would certainly note that. I wouldn't want any equipment in my house without a model number or serial number. Well, you can't install used equipment. I can't come in and put a used water heater in your house. I'm a licensed professional. That's illegal for me to even put a used toilet in. That's illegal for me to put that old water heater in. Even if your neighbor got a water heater 2 years ago and wanted the tankless, I'm not putting that water heater in your house. It's been used at that point. So there is a process to go through to get that used equipment recertified by the factory. So you pay to ship it up at the factory, they recertify it, they'll ship it back to you saying certified good, and then I can put that in your house, but nobody's going to go through that hassle. Yes? A TMP valve? Yes. If not, it comes with a port to put one in. So there should always be one. It needs to be either on top or the side of the tank.
Are the new ones all delivered with the new valve?
Everyone I've seen, Bradford White for a while was giving their people options. Theirs came in the box.
I've had customers getting from major companies, your competitors, where they have these independent techs coming out and saying, oh, your valve looks like it's okay, I won't have to charge you for a new one, I'll just put that one over. Yeah, it's from me. And I'm told that they come with it.
Yeah, every Rheem I get comes with it. So if, once again, the guy running out of the back of his truck wants that new valve so we can sell it to another customer and put it in, then I guess he would take the time to unthread it and put a new one in. That's very bad practice, but those are the things you definitely need to let your homeowners know and say, hey, this didn't come like this. Somebody altered this out of the box. Come have a professional look at it. That's really what we're all getting paid for, is that right there. Yes?
Your opinion on water heater installations where they're using flexible or braided water supply lines to connect to the water heater, part A, and they're using those for the TNT valve?
There's nothing that says you can't. They're approved water connections for that water heater, so that's okay. We, as our company, we don't use them. We run metallic pipe off the water heater, whether it's a electric or a gas, and then we'll transition into whatever pipe they have. But there's nothing wrong with that. In fact, most of the country, especially out west, that's all they use. So that's okay. That's another point to leak that we don't want to come back and deal with. Our whole motto is, no callbacks. Let's reduce any possible situation that's going to have us have a callback. So we're going to do it this way, where 99.9% of the time it's going to be good to go. Yes?
So the
pan under the water heater, does common sense says it needs to be big enough to cover the drain valve, but is that a requirement?
I couldn't find it. I knew that question was going to be asked, so I actually tried to look at that last week. I couldn't find that anywhere. What I typed in there was what they have for pans, basically. So another one of those better practices things. If we're going to put a pan in, let's make sure it covers what it needs to. Also, if we're going to put a pan in, let's make sure that it's not extremely tied up to that water heater, because then at that point, once you take up all the volume in that pan, there's going to be nowhere for anything to overflow, and that drain's not going to be able to catch up. So the answer to that is no, I haven't found anything. But I believe your continuing education time is up.